right, this is CS50, and this is week 6, wherein we finally transition from Scratch to C to now Python. And indeed, this is going to be somewhat of a unique experience in that just like a few weeks past, perhaps for the first time, and now today, you're going to learn a new language. But the goal isn't just to throw another fire hose of content and syntax and whatnot at you, but rather to really equip you all to actually teach yourself new languages in the future. And so indeed, what we'll do today, what we'll do this coming week, is sort of prepare you to stand on your own. And once Python is passé and the world has moved on to some other language in some number of years, you'll be well equipped to figure out how to wrap your mind around some new syntax, some new language, and solve problems as well. Now, you recall in week 0, this is where we started, just saying hello to the world. And that quickly escalated just a week later in C to be something much, much more cryptic. And if you've still sort of struggled with some of the syntax, find yourself checking your notes or your previous code, like that's totally normal. And that's one of the reasons why there are languages besides C out there, among them this language called Python. Humans over the decades have realized, gee, that wasn't necessarily the best design decision. Or humans have realized, wow, you know what? Now that computers have gotten faster with more memory and faster CPUs, we can actually do more with our programming languages. So just as human languages evolve, so do actual programming languages. And even within a programming language, there's typically different versions. We, for instance, have been using version C11 of C, which was updated in 2011. But Python itself continues to evolve. And it's now up to version 3+. And so there, too, these things will evolve in the coming days. Thankfully, what you're about to see is hello world for the 3rd time. But it's going to be literally this. None of the crazy syntax above or below. Fewer semicolons, if any. Fewer curly braces. And really, a lot of the distractions get out of the way. So to get there, let's consider exactly how we've been programming up until now. So you write a program in C, and you've got hopefully no syntax error, so you're ready to build it, that is compile it. And so you've run make, and then you've run the program like /hello. Or if you think back to week 2, where we took a peek underneath the hood of what make is doing, it's really running the actual compiler, something called clang, maybe with some command line arguments, creating a program called hello, and then you could do /hello. So today, you're going to start doing something similar in spirit, but fewer steps. No longer will you have to compile your code and then run it, and then maybe fix or change it, and then compile your code and run it, and then repeat, repeat. The process of running your code is going to be distilled into just a single step. And the way to think of this for now is that whereas C is frequently used as indeed a compiled language, whereby you convert it first to zeros and ones, Python's going to let you speed things up, whereby you, the human programmer, don't have to compile it. You're just going to run what's called an interpreter, which by design is named the exact same thing as the language itself. And by running this program installed in VS Code or eventually on your own Macs or PCs, this is just going to tell your computer to interpret this code and figure out how to get down to that lower level of zeros and ones. But you don't have to compile the code yourself anymore. So with that said, let's consider what the code is going to look like side by side. In fact, let's look back at some Scratch blocks, just like we did with C in week 1, and do some side by sides. Because even though some of the syntax this week and beyond is going to be different, like the ideas are truly going to be the same. There's not all that much intellectually new just yet. So whereas in week 0, we might have said hello to the world with this purple puzzle piece, today, of course, or rather in week 1, it looked like this in C. But today, moving forward, it's going to quite simply look like this instead. And if we go back and forth for just a moment, here again is the version in C, noticing the very C-like characteristics. And just at a glance here, in Python, I claim it's now this. What do you apparently need not worry about anymore? What's gone? So semicolon is gone. And indeed, you don't need those to finish most of your thoughts anymore. Anything else? So the \n is absent, and that's kind of curious because we're still going to get a new line, but we'll see that it's become the default. And this one's a little more subtle, but now the function is called print instead of printf. So it's a little more familiar in that sense. All right, so when it comes to using libraries, that is code that other people have written, in the past we've done things like #include cs50.h to use CS50's own header file, or standard IO, or standard lib, or string, or any number of other header files you have all used. Well, moving forward, we're going to give you for this first week a similar CS50 library, just very short-term training wheels that will quickly take off, because in reality, it's a lot easier to do things in Python, as we'll see. But the syntax for this now is going to be to import the CS50 library in this way. And when we have now this ability, we can actually start writing some code right away. In fact, let me switch over to VS Code here. And just as in the past, I'll create a new file, but instead of creating something called .c, I'm going to go ahead and create my first program called hello.py using code space hello.py. That, of course, gives me this new tab. And let me actually quite simply do what I proposed, print, quote unquote, hello world, without the \n, without the semicolon, without the f in print. And now let me go down to my terminal window, and I don't have to compile it. I don't have to do // I instead run a program called Python, whose purpose in life is now to interpret my code top to bottom, left to right. And if I run Python of hello.py, crossing my fingers as always, voila. Now I have printed out hello world. So we seem to have gotten the new line for free in this sense, where it's automatically happening. The $ isn't weirdly on the same line like it once was in week 1, but that's just a minor detail here. If we switch back to now some other capabilities, well, indeed, with the CS50 library, you can also not just import the library itself, but specific functions. And you'll see that temporarily, we're going to give you a helper function called getString, just like in C, that just makes it work exactly the same way as in C. And we'll see a couple of other functions that will just make life easier initially, but quickly will we take those training wheels off so that nothing is indeed CS50 specific. All right, well, how about functions more generally in Python? Let's do a whirlwind tour, if you will, much like we did in that first week of C, comparing one to the other. So back in our world of Scratch, one of the first programs we wrote was this one here, whereby we asked the human their name. We then used the return value that was sort of automatically stored in this answer variable as a second argument to join, so that we could say hello David or hello Carter. So this was back in week 0. In week 1, we converted it to this. And here's a perfect example of things like escalating quickly. And again, this is why we start in Scratch. There's just so much distraction here to achieve the same idea. But even today, we're going to chip away at some of that syntax. So in C, we had to declare the argument as we had to declare the variable as a string here. We, of course, had the semicolon and more. Well, in Python, the comparable code now is going to look more simply like this. So semicolon is again gone on both lines, for that matter. So that's good. What else appears to have changed or disappeared? Yeah? Yeah, so I didn't have to specifically say that answer is now a string. And indeed, Python is dynamically typed. And in fact, it will infer from context exactly what it is you are storing in that variable. Other details that seem a little bit different. A little bit different. What else jumps out at you here? I'll go back. This was the C version. And maybe focus now on the second line, because we've rather exhausted the first. Here's now the Python version. What's different here? Yeah? Yeah, there's no %s anymore. There's no second argument at the moment, per se, to print. Now, it is still a little weird. It's as though I've deployed some addition here arithmetically, but that's not the case. Some of you have programmed before, and plus, some of you might know, means what in this context? So to combine, or more technically, anyone know the buzzword? Yeah. To concatenate. So to concatenate is like the fancy way of what Scratch calls joining, which is to take one string on the left, one string on the right, and to join them together, to glue them together, if you will. So this is not addition. It would be if it were numbers involved instead. But because we've got a string, hello, comma, and another string implicitly in this variable based on what the human typed in response to this getString function, that's going to concatenate hello, comma, space, and then David or Carter or whatever the human has typed in. But it turns out there's going to be different ways to do this in Python. And we'll show you a few different ones. And here, too, try not to get too hung up on or frustrated by all of the different ways you can solve problems. Odds are you're going to be picking up tips and techniques for years to come if you continue programming. So let's just give you a few of the possible ways. So here's a second way. You could print out hello, comma, David or hello, comma, Carter. But what has changed? In the previous version, I used concatenation explicitly. And the space here is important grammatically, just so we get that in the final phrase. Now I'm proposing to get rid of that space, to add a comma outside of the double quotes as well. But if you think back to C, this probably just means that print, similar in spirit to printf, can take not just one argument, but even two. And in fact, because of this comma in the middle that's outside of the double quotes, it's hello, comma, and then it will be automatically concatenated with, even without using the plus, to whatever the value of answer is. And by default, just for grammatical prettiness, the print function always gives you a space for free in between each of the multiple arguments you pass in. We'll see how you can override that down the line. But for now, that's just another way to do it. Now, perhaps the better if slightly cryptic way to do this, or just the increasingly common way, is probably this third version, which looks a little weird too. And probably the weirdness jumps out. We've suddenly introduced these like curly braces, which I promised were mostly gone, and they are. But inside of this string here, I've done a curly brace, which might mean what, just intuitively? And here's sort of an example of how you learn a new language. Just kind of infer from context how Python probably works. What might this mean? Yeah?
Able to tell that this is not one of the actual statements inside the double quotes. It's a variable that's being put in.
Yeah, so this is an indication, because of the curly braces, because this is the way Python was designed, that we want to plug in the value of answer, not literally ANSWER. And the fancy word here is that the answer variable will be interpolated. That is, substituted with its actual value. But, and this is actually weird looking. This was introduced a few years ago to Python. What else did I have to change to make these curly braces work, apparently? Yeah? Yeah, there's this weird f. And so it's sort of like part of printf, but now it's inside the it's inside the parenthesis there. This is just the way Python designed this. So a few years ago, when they introduced what are called format strings, or f strings, you literally prefix your quoted string with the letter f. And then you can use trickery like this, like putting curly braces so that the value will be substituted automatically. If you forget the f, you're going to literally see hello, comma, curly brace, answer, close curly brace. If you add the f, it's indeed interpolated. The value is plugged in. All right, questions on how we can just say hello to the world via Python in this case? Yeah? If you do this without the f, if you omit the f, you will literally see HELLO, comma, curly brace, ANSWER, close curly brace. So in fact, let's do this. Let me go back to VS Code here quickly. I've still got my file called hello.py open. And let me go ahead and change this ever so slightly. So I'm going to go ahead and let's say from CS50 import getString. And that's just the new syntax I propose using to import a function from someone else's library. I'm going to now go ahead and ask the question, let's go ahead and use getString, storing the result and answer. So getString, quote unquote, what's your name, question mark. And then on this line, I'm going to deliberately make a mistake here, exactly to your question. Let me just say hello, comma, answer. And just this. Now, even though answer is a variable, Python's not going to be so presumptuous as to just plug in the value of a variable called answer. What it's going to do, of course, is if I type in my name, whoops, I typed too fast. Let me go ahead and rerun that again. If I run python of hello.py, type in my name and hit enter, I get hello, comma, answer. Well, let me do one better. Let me apply these curly braces as before. Let me rerun python of hello.py. What's your name? DAVID. And here's again the answer to your question. Now we get literally the curly braces. So the fix here ultimately is just going to be to add the f there, rerun my program again with DAVID, and now hello, comma, David. So this is admittedly a little more cryptic than the ones with the plus or the comma, but this is just increasingly common. Why? Because you can read it left to right. It's nice and convenient. It's less cryptic than the %s is. So it's sort of a new and improved version, if you will, of printf in C, based on decades of experience of programmers doing things like this. Questions on printing in this way? We're now on our way to programming in Python. Anything? All right. Well, what more can we do with this language here? Well, let me propose that we consider that we have, for instance, a few other features that we can add to the mix as well, namely, let's say some data types as well. So let me flip over here to back to the slides. And there's different data types in Python, as we'll soon see. But they're not as explicit as we already saw by using a string from getString. You don't have to explicitly state what it is. But you saw, recall in C, all of these various data types. And then in Python, kind of nicely enough, this list is about to get shorter. And so here is our list in C. Here is an abbreviated list in Python. So we're still going to have strings, but they're going to be more succinctly called strs now, str. We're still going to have ints for integers. We're still going to have floats for floating point values. We're even going to have bools for true and false. But what's missing now from the list is is long and float. And why is that? Or rather, long and double. Well, recall that in C, those used more bits. Well, in Python, the smaller data types previously, int and float, themselves just use more bits for you. And so you don't need to distinguish between small and large. You just use one data type, and the language gives you a bigger range than before. It turns out, though, there's going to be some other features as well of Python, these data types, one of which will be called range, another of which will be list. So gone will be arrays. We'll actually use something literally called a list. Tuples, sort of like XY pairs for coordinates and things like that. Dict for dictionaries. So we'll have built-in capabilities for storing keys and values, we'll see. And even a set. Sort of mathematically, a set is like a collection of values, but it automatically gets rid of duplicates for you. So all of these things we could absolutely implement in C if we wanted. And indeed, in problem set 5, you've been implementing your very own spell checker using some form of hash table. Well, it turns out that in Python, you can solve those same problems, but perhaps a little more readily. In fact, let me go back over here to VS Code, and let me propose that I do the following. Let me go ahead and create a file called dictionary.py. Let me propose that I try to implement, say, problem set 5, our spell checker, in Python instead of C, and achieve ultimately the same kind of behavior whereby I'll be able to spell check a whole bunch of words. So this is jumping the gun a little bit, because you're about to see syntax we'll revisit over the course of today. But for now, I've got a new file called dictionary.py. And let me begin to create some placeholders for functions. We'll see in just a bit that in Python, you can define a function called check. And that check function can take a word as its input. And I'll come back to this in just a moment. In Python, I can define a second function like load, which itself will take a whole dictionary, just like in problem set 5. And I'll go ahead and come back to the implementation of this. Meanwhile, we might similarly implement a function called size, which takes no arguments, but ultimately is going to return the size of my dictionary of words. And then lastly, for consistency with problem set 5, we might define an unload function whose purpose in life is to free any memory that you've been using just to give it back to the computer. Now, odds are, whether you're still working on Speller or have finished Speller, like you wrote a decent amount of lines of code. And indeed, it's been, by design, a challenge. But one of the reasons for these higher level languages like Python is that you can stand on the shoulders of programmers before you and solve very common problems much more quickly, so that you can focus on building your new app or your web application or your own project to solve problems of interest to you. So at the risk of crushing some spirits, let me propose that in Python, if you want a dictionary for something like a spell checker, well, that's fine. Go ahead and give yourself a variable like words to store all of those words, and just assign it equal to a dictionary, or dict for short, in Python. That will give you a hash table. Now, it turns out in Speller, recall, you don't need to worry about words and definitions. It's just about spell checking the words. So strictly speaking, we don't need keys and values. We just need keys. So I'm going to save myself a few more keystrokes by just saying that technically in Python, using a set suffices. Again, a set is just a collection of values with no duplicates. But they don't necessarily have keys and values. It's just one or the other. But now that I have, on line 1, I claim, the equivalent in Python of a hash table, I can actually do something like this. Here's how I might implement the check function in Python. If the word passed into this function is in my variable called words, well, return true. Else, go ahead and return false. Done. Wait, you're thinking, if anything at all, maybe we want to handle lowercase instead of just uppercase and lowercase. Well, you know what? In Python, if you want to force a whole word to lowercase, you don't have to iterate over it with a loop. You don't have to use any of that C-type functions or anything. Just say word.lower, and that will convert the whole thing to lowercase for parity with the dictionary. All right, how about something like the load function in Python? Well, in Python, you can open files just like in C. For instance, in Python, I might do open the dictionary argument in read mode, just like fopen in Python. I might do something like this. For each line in that file, let me go ahead and add to my words variable that line. And then let me go ahead and close that file. And I think I'm done. I'm just going to go ahead and return true, just because I think I'm already done. Now here too, I could nitpick a little bit. Technically, if I'm reading in every line from the file, every line in the dictionary ends with technically a \n. But there's an easy way to get rid of that, just like you might in C with an alternative syntax. What I'm actually going to do is this. Let me grab from the current line the current word by stripping off with reverse strip, rstrip, a function we'll again see, that just gets rid of the trailing new line, the \n at the end of that line. And what I really want to do then is add this word to that dictionary. Meanwhile, if I want to figure out what the size is of my dictionary, well, in C, you're probably writing code to iterate over all of those lines, and you're just going to count them up using a variable. Not so in Python. You can just return the length of those words. And better still, in Python, you don't have to manage your own memory. No more malloc, no more free, no more manual thinking about memory. The language just deals with all of that for you. So you know what? It suffices for me to just return true and claim that unloading is done for me. And that's it. Again, whether you're in the middle of or already finished, this might perhaps suggest some frustration, but also enlightenment in that this is why higher level languages exist. You can build on top of the same principles, the same ideas with which you've been dealing, struggling even this past week, but you can now express yourself all the more succinctly. Like this one line implements a hash table for you. And all of this now just uses that hash table in a simpler way. Any questions now on this? Keeping in mind that the point, nonetheless, of Speller and CS50 is to understand what's really going on underneath the hood, and better still, to notice this. This might seem all rather amazing, but let me go ahead and do this. I've actually got a couple of versions of Speller written here, and I've got a version written in C that I won't show the source code for, but I'm going to go ahead and make that version of Speller in C. And I'm going to go ahead here and, let's say, split my window here for just a moment. And I'm going to go into a Python version of Speller, really that I just wrote. And on the left-hand side here, let me go ahead and run Speller, the version I compiled in C, using a big text like the Sherlock Holmes text, which is a whole lot of words in it. And on the right-hand side, let me run Python of speller.py, which is a separate file I wrote in advance, just like we give you speller.c. And I'll similarly run this on the Sherlock Holmes text. And I'm going to do my best to hit enter on the left and the right of my screen at the same time. But we should see, hopefully, the same list of misspelled words and the timings thereof. So here we go on the right. Here we go on the left. All right. Sort of a race to see which one wins here. C is on the left. Python is on the right. OK, interesting. Hopefully, Python's close behind. Note that some of this is internet delay, and so it might not necessarily be a crazy number of seconds, but the system is indeed using, if we measure at a low level, how much time the CPU spent executing my code. C took a total of 1.64 seconds. That was pretty fast, even though it took a moment more for all of the bytes to come over the internet. The Python version, though, took what? 2.44 seconds. So what might an inference be? I mean, one, maybe I'm just better at programming in C than I am in Python, which is probably not true. But what else might you infer from this example? Should we maybe give up on Python, stick with C? No? So what might be going on here? Like, why is the Python version that I claim is correct, and I think the numbers all line up, just not the times, where's the trade-off here? Well, here again is sort of this design trade-off. Yeah? Yeah, exactly. In order to save the human programmer time, there's a lot more features built into Python, more functions, more automatic management of memory, and so forth. And you have to pay a price. Like, someone else's code is doing all of that work for you. But if they've written some number of lines of code, those are just more lines of code that need to be executed for you. Whereas here, the computer is, at the risk of oversimplifying, only running my lines of code. So there's just less overhead. And so this is a perpetual trade-off. Typically, when using a more user-friendly, a more modern language, one of the prices you might pay is performance. Now, there's a lot of smart computer scientists in the world, though, trying to push back on those same trade-offs. And so these interpreters, like the command I wrote, Python, technically can, especially if you run a program again and again, they can actually sort of secretly, behind the scenes, compile your code for you down to zeros and ones. And then the second, the third, the fourth time you run that program, it might very well be faster. So this is a bit of a head fake here in that I'm running them once and only once, but we could bend benefit over time if we kept running the Python version again and again and perhaps fine-tune the performance. But in general, there's going to be this trade-off. Now, would you rather spend the 60 seconds I wrote implementing a spell checker, or the 6 hours, 16 hours you might be or have spent implementing the same in C? You know, probably not. For productivity's sake, this is why we have these additional languages. Just for fun, let me flip over to another screen here and open up a version of Python that's actually on in just a second, on my own Mac instead of the cloud, so that I can actually do something with graphics. So here I just have a black and white terminal window on my very own Mac, and I've pre-installed Python just like we've done so for VS Code in the cloud for you. Notice that I've got this photo of perhaps one of your favorite TV shows here with the cast of The Office. Notice all of the faces in this image here. And let me propose that we try to find one face in the crowd, sort of CSI style, whereby we want to find perhaps the Scranton Strangler, so to speak. And so here is an example of this guy's face. Now, how do we go about finding this specific face in the crowd? Well, our human eyes obviously can pluck him out, especially if you're familiar with the show. But let me go ahead and do this instead. Let me go ahead and propose that we run code that I already wrote in advance here. This is a Python program with more lines of code that we won't dwell on for today, but it's meant to motivate what we can do from a pillow library, implying a Python image library. I want to import some type of information, some feature called image, so that I can manipulate images, not unlike our own problem set 4. And this is kind of powerful. In Python, you can just import face recognition as a library that someone else wrote. From there, I'm going to create a variable called image. I'm going to use this face recognition's library's load image file function. It's a little verbose, but it's similar in spirit to fopen. And I'm going to open office.jpg. I'm going to then declare a second variable called face locations, plural, because what I'm expecting to get back, per the documentation for this library, is a list of all of the faces locations that are detected. All right, then I'm going to iterate over each of those faces using a for loop that we'll see in more detail. I'm going to then infer what the top, right, bottom, and left corners are of that face. And then what I'm going to do here is show that face alone if I've detected the face in question. So let me go ahead here and run detect.py. And we'll see not just the one face we're looking for, but if I run python of detect.py, it's going to do all of the analysis. I'll see a big opening here now of all of the faces that were detected in this here program. OK, some better than others, I guess, if you zoom in on catching someone, typical Angela. If you now want to find that one face, I think we need to train the software a bit more. So let me actually open up a second program called recognize that's got more going on. But let me, with a wave of a hand, point out that I'm now loading not only the office.jpg, but also toby.jpg to sort of train the algorithm to find that specific face. And so now, if I run this second version, recognize.py, with Python of recognize.py, hold my breath for just a moment. It's analyzing presumably all of the faces. You see the same original photo, but do you see one such face highlighted here? This version of the code found Toby, highlighted him with this green, and voila, we have face recognition. So for better or for worse, this is what's happening increasingly societally nowadays. And honestly, even though I didn't write the code live, because it's a good dozen or more lines of code, it's not terribly many. And literally all the authorities, all we have to do is import face recognition, and voila, you have access. Like, these technologies are here already. But let's consider for just a moment, how did we find Toby? Like, how might that library, even though we're not going to look at its implementation details, how does it find Toby and distinguish him from all of these other faces in the crowd? What might it be doing intuitively? Think back even to pset 4, like what you yourselves have access to data-wise. Yeah?
Since you gave it an image of Toby's face before,
Mm-hmm.
it probably looks at, like, are the pixels in one area same as in another area? And a lot of them are the same from that reference image to this new image. And it's going to say, hey, a lot of the similar pixel arrangements are here and here. So we can safely guess that this is the same person.
Yeah, exactly. And to summarize for camera here, we have trained the software, if you will, by giving it a photo of Toby's face. So by looking for the same or really similar pixels, especially if it's a slightly different image of Toby, we can perhaps identify him in the crowd. And what really is a human face? Well, at the end of the day, the computer only knows it as a pattern of bits, or really at a higher level, a pattern of pixels. So maybe a human face is perhaps best defined in general as like 2 eyes and a nose and a mouth, that even though all of us look similar structurally, odds are the measurement between the eyes and the nose and the width of the mouth, the skin tone, and all of these other physical characteristics are patterns that software could perhaps detect and then look sort of statistically through the image, looking for the closest possible match to these various measurements, shapes, colors, and sizes, and the like. And indeed, that might be the intuition, but what's powerful here again is just how easy and readily available this technology now is. All right, so with that said, let's propose to consider what more we can do with Python itself, get back to the fundamentals so that you yourselves can start to implement something along those same lines. So besides having access to things like a getString function, the CS50 library provides a few other things as well. Namely, in C, we had these. But in Python, we're going to have fewer. In Python, our library short term is going to give you not only getString, but also getInt and getFloat. Why? It's actually just kind of annoying, as we'll soon see, to get back an integer or a float from a user and just make sure that it's an int and a float and not like a word like cat or dog or some string that's not actually a number. Well, we can import not just the specific function getString, but we can actually import all of these functions one at a time like this, as we'll soon see. Or you can even in Python import specific functions from a file. One of you asked a while back, when you include something like CS50.h or standardio.h, you're actually getting all of the code in that file, which potentially can add bulk to your own program or time. In this case, when you import specific functions from Python, you can be a little more narrowly precise as to what it is you want to have access to. All right, so with that said, let's go ahead and see what conditionals look like in Python. So in the left-hand side, again, here we'll see Scratch. And here, for instance, was just kind of a contrived example asking if x is less than y, then say x is less than y. In C, it looked like this. In Python now, it's going to look like this instead. And here's before in C, and here's after. And just to call out a few of the obvious differences, what has changed in Python for conditionals, it would seem? Sort of, what's the difference? Yeah. Yeah, so there's no more curly braces, and indeed you don't use those. What appears to be taking their place, if you might infer? What seems to have taken their place? What do you think? So the colon at the start of this line here, but also even more important now is this indentation below it. So some of you, and we know this from office hours, have a habit of like indenting everything on the left, right? And it's just kind of this crazy mess to look at. Frustrating for you, surely. But C and Clang is pretty tolerant when it comes to things like white space in a program. Python, They realized years ago that let's help humans help themselves and just require standard indentation. So 4 spaces would be the norm here. But because it's indented below that colon, that indeed indicates that this now is part of that condition. Something else has gone missing versus C in this conditional. What else is a little simplified? Yeah, so no more parentheses. You can still use them, especially when you need to logically to do order of operations like in math. But in this case, if you just want to ask a simple question like if x less than y, you can just do it like that. How about when you have an if else? Well, this is almost the same here with these same changes. In C, this looked like this. And it's starting to get a bit bulky, at least if we use our curly braces in this way. In Python, we can tighten things up further, even though strictly speaking in C, you don't always need the curly braces. But here, gone are the parentheses again. Gone are the curly braces. Indentation is consistent. And we've just added another keyword else with a colon, but no more semicolons as well. How about something larger like this? An if, else, if, else. This one's a little curious, but in C it looked like this. If, else. In Python, it now looks like this. And there's perhaps one curiosity here that honestly, all these years later, I still can't remember how to spell it half the time. What's weird about this? What do you spot as different? Yeah, over here. Yeah, instead of else if, it's elif. Why? Apparently else space if was just too many keystrokes for humans to type, so they condensed it into this way. Probably means it's a little more distinguishable too for the computer between the if and the else too, but just something to remember now. It's indeed elif and not else if. All right, so what about variables in Python? I've used a couple of them already, but let's distill exactly how you define and declare these things as well. So in Scratch, if we wanted to create a variable called counter and set it equal initially to 0, we would do something like this. Specify that it's an int, use the assignment operator, end the thought with a semicolon. In Python, it's just simpler. You name the variable, you use the assignment operator as before, you set it equal to some value, and that's it. You don't mention the type, you don't mention the semicolon or anything more. What if you want to change a variable like the counter by 1, that is incremented by 1? You have a few different ways here in C. We saw syntax like this, where you can say counter equals counter plus 1, which again feels like illogical. How can counter equal counter plus 1? But again, we read this code really right to left, updating its value by 1. In Python, it's almost the same. You just get rid of the semicolon. So that logic is there. But recall in C, we could do something slightly different that we can also do in Python. In Python, you can also more succinctly do this. Plus equals, and then whatever number you want to add, or you can even change it to subtract if you prefer. Sadly, gone is something you've probably typed a whole lot. What was the other way you can add 1? Plus plus is no more, sadly, in Python. Just too many ways to do the same thing, so they got rid of it in favor of just this syntax here. So keep that in mind as well. What about loops? When you want to do something in Python again and again? Well, in Scratch, in week 0, here's how we meowed 3 times specifically. In C, we had a couple of ways of doing this. This was like the more mechanical approach where you create a variable called I, you set it equal to 0. You then do while I is less than 3, the following, and then you yourself increment I again and again. Mechanical in the sense that like you have to implement all of these gears and make them turn yourself, but this was a correct way to do that. In Python, we can still achieve the same idea, but we don't need the int keyword. We don't need any of the semicolons. We don't need the parentheses. We don't need the curly braces. We can't use the plus plus, so maybe that's a minor step backwards if you're a fan. But otherwise, the code, the logic is exactly the same. But there's other ways to achieve this same idea. Recall that in C, we could also do this. You could use a for loop, which it does exactly the same thing. Both are correct. Both are arguably well designed. It's kind of to each their own when it comes to choosing between these. In Python, though, we're going to have to think through how to do this. So you don't do the same for loop as in C. The closest I could come up with is this, where you say for I, or whatever variable you want to do the counting, in, literally, the preposition, and then you use square brackets here. And we've used square brackets before in the context of like arrays and things like that. And the 0, 1, 2 looks like an array in some sense, even though we've also seen arrays with curly braces. But these square brackets for now denote a list. Python does not have arrays. An array is that contiguous chunk of memory back to back to back that you have to resize somehow by moving things around in memory, as per 2 weeks ago. In Python, though, you can just create a list like this using square brackets. And better still, as we'll see, you can add or even remove things from that list down the road. This, though, is not going to be very well designed. This will work. This will iterate in Python 3 times. But what might rub you the wrong way about this design, even if you've never seen Python before? How does this example not end well? Yeah? Yeah, like if you're making a large list, you have to type out each one of these numbers, like comma 3, comma 4, comma 5, comma dot 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 50, comma dot 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 500. Like surely that's not the best solution to have all of these numbers on the screen wrapping endlessly on the screen. So in Python, another way to do this would be to use a function called range, which technically is a data type unto itself. And this returns to you as many values as you ask for it. Range takes some other arguments as well, but the simplest use case here is if you want back the numbers 0, 1, and 2, a total of 3 values, you say, hey, Python, please give me a range of 3 values. And by default, they start at 0 on up. But this is more efficient than it would be to hard code the entire list at once. And the best metaphor I could come up with is something like this. Like here, for instance, is a deck of cards. This is sort of normal human size. And there's presumably 52 cards here. So writing out 0 through 51 on code would be a little ridiculous for the reasons you note. It would just be very unwieldy and ugly and wrapping and all of that. It would be the virtual equivalent of me like handing you all of these cards at once to just deal with. And right, they're not that big, but like it's a lot of cards to hold on to. It requires a lot of memory or physical storage, if you will. What range does metaphorically is if you ask me for 3 cards, I hand you them one at a time like this, so that at any point in time, you only have one number in the computer's memory until you're handed the next. The alternative, the previous version, would be to hand me all 3 cards at once or all 52 cards at once. But in this case, range is just way more efficient. You can do range of 1,000. That's not going to give you a list of 1,000 values all at once. It's going to give you 1,000 values one at a time, reducing memory significantly in the computer itself. All right, so besides this, what about doing something forever in Scratch? Well, we could do this literally with a forever block, which didn't quite exist in C. In C, we had to hack it together by saying while true, because true is by definition, TRUE, always true. So this just deliberately induces an infinite loop for us. In Python, the logic's going to be almost the same. And infinite loops in Python tend to actually be even more common, because you can always break out of them, as you could in C. In Python, it looks like this. And this is slightly more subtle, but gone are the curly braces, gone are the parentheses, but ever so slight difference too. A capital T for true, and it's going to be a capital F for false. Stupid little differences. Eventually, you're going to mistype one or the other. But these are the kinds of things to keep an eye out and to start recognizing in your mind's eye when you read code. Questions now on any of these building blocks? Yeah? In the for loop was it was set to 0 on the first iteration, then 1 on the next, then 2 on the third. And the same thing for range. It just doesn't use up as much memory all at once. Other questions now on any of these building blocks of Python? No? All right, well, let's go ahead and build something a little more than hello. Let me propose that over here we implement maybe the simplest of calculators here. So let me go back to VS Code here, open my terminal window, and open up, say, a file called calculator.py. And in calculator.py, we'll have an opportunity to explore some of these building blocks, but we'll allow things to escalate pretty quickly to more interesting examples so that we can do the same thing ultimately as well. And in fact, let me go ahead and do this moreover. I've brought some code with me in advance. For instance, something called calculator 0.c from the first week of C. And let me go ahead and split my window here, in fact, so that I can now do something like this. Let me move this over here. Calculator.py. So now I have on the left of my screen calculator.c, or calculator0.c, because that's the first version I made, and calculator.py on the right. Let me go ahead and implement really the same idea here. So on the right-hand side, the analog of including CS50.h would be from CS50 import getInt, if I want to indeed use this function. Now I'm going to go ahead and give myself a variable x without defining its type. I'm going to use this getInt function, and I'm going to prompt the user for x, just like in C. I'm then going to go ahead and prompt the user for another int, like y, here, just like in C. And at the very end, I'm going to go ahead and do print x plus y. And that's it. Now, granted, I have some comments in my C version of the code, just to remind you of what each line is doing. But I've still distilled this into like 6 lines, or really 4 if I get rid of the blank line. So it's already perhaps a bit tighter here. But there's also, it's tighter because something really important historically is missing. What did I seem to omit altogether that we haven't really highlighted yet? Yeah. Yeah, the main function is gone. And in fact, maybe you took for granted that it just worked a moment ago when I wrote hello. But I didn't have a main function in hello either. And this, too, is a feature of Python and a lot of other languages as well. Instead of having to adhere to these long-standing traditions, if you just want to write code and get something done, fine. Just write code and get something done without necessarily all of this same boilerplate. So whatever is in your Python file, left indented, if you will, by default, is just going to be the code that the interpreter runs top to bottom, left to right. Well, let me go ahead now and run code like this. Let me go ahead and open back up my terminal window, run Python of calculator.py, and I'll do x is 1, y is 2. And as you might expect, it gives me 3. Slight aesthetic bug. I put my space in the wrong place here, so that's a newbie mistake. Let me fix that aesthetically. Let me rerun Python of calculator.py, type in 1, type in 2, and voila, there is now my same version again. But let me propose now that we get rid of this training wheel. We don't want to keep taking one step forward and then two steps back by adding these training wheels. So let me instead do this. In my version of calculator.py, suppose that we take away already the training wheel that is the CS50 library here. And let me instead then use just Python's built-in function called input, which literally does just that. It gets input from the user. And it stores it, as before, in x and y. So this is not CS50 specific. This is real-world Python programming. Well, let me go ahead and run, again, Python of calculator.py. And of course, if x is 1 and y is 2, x plus y should, of course, still be 3. It's apparently 12, according to Python, until CS50's library gets involved. But does anyone want to infer what just went wrong? Yeah? Exactly. The input function, by design, always returns a string of text. After all, that's what the human typed in. And even though, yes, I typed the number keys on the keyboard, it's still coming back as all text. Now, maybe we should use like a getInt function. Well, that doesn't exist in Python. All you can do is get textual input, a string from the user. But we can convert one to the other. And so a fix for this, so that we don't accidentally concatenate, that is, join x plus y together, would be to do something like this. Let me go back to my Python code here. And whereas in C, we could previously do typecasting. We could convert one type to another. That generally wasn't the case when you were doing something complex like a string to an int. You could do a char to an int and vice versa. But for a string, recall there was a special function in the C-type library called a to I, like ASCII to integer. That's the closest analog here. And in fact, the way to do this in Python would be to use a function called int, which indeed is the name of the data type too, even though I have not yet had to type it. And I can convert the output of the input function automatically from a string immediately to an int. And now, if I go back to my terminal window, rerun Python of calculator.py with 1 and 2 for x and y, now I'm back in business. So that then is, for instance, what the CS50 library does, if temporarily this week, is it just deals with the conversion for you. And in fact, bad things could happen if I type the wrong thing, like dog or cat instead of a number. But we'll cross that bridge in just a moment as well. All right, what if we do something slightly different now with our calculator? Instead of just addition, let me go ahead and do, how about, instead of addition, let's do division instead. So z equals x divided by y, thereby giving me a third variable z. Let me go ahead and run Python of calculator.py again. I'll type in 1. I'll type in 3 this time. And what problem do you think we're about to see? Or is it gone? What happened when I did this in C, albeit with some slightly more cryptic syntax? When I divided one number, like 1 divided by 3. Anyone recall? Yeah. Yeah, so it would round down to the nearest integer, whereby you experience truncation. So if you take an integer like 1, you divide it by another integer like 3, that technically should be 0.33333, infinitely long. But in C, recall, you truncate the value. If you divide an int by an int, you get back an int, which means you get only the integer part, which was the 0. Now, Python actually handles this for us and avoids the truncation, but it leaves us still with one other problem here, which is going to be, for instance, not necessarily visible at a glance. This looks correct. This has solved the problem in C. So truncation does not happen. The integers are automatically converted to a floating point value. But what other problem did we trip over back in week 1? What else got a little dicey when dealing with simple arithmetic? Anyone recall? Well, the syntax in Python's a little different, but let me go ahead and do this. It turns out in Python, if you want to see more significant digits than what I'm seeing here by default, which is a dozen or so, let me go ahead and print out z as follows. Let me first print out a format string, because I want to format z in an interesting way. And notice this would have no effect on the difference. This is just a format string that, for no compelling reason at the moment, is interpolating z in those curly braces using an f string or format string. If I run this again with 1 and 3, we'll see indeed the exact same thing. But when you use an f string, you indeed have the ability to format that string more precisely. Just like with %f in Python, you could start to fine tune how many significant digits you see. In C, Rather, in Python, you can do the same, but the syntax is a little different. If you want the computer to interpolate z and show you 50 significant digits, that is 50 numbers after the decimal point, syntax is similar to C, but it's a little different. You literally put a colon after the variable's name. .50 means show me the decimal point and then 50 digits to the right. And the F just indicates, please treat this as a floating point value. So now if I rerun Python of calculator.py, divide 1 by 3, unfortunately, Python has not solved all of the world's problems for us. This, again, was an example of floating point imprecision. So that problem is still latent. So just because the world has advanced doesn't necessarily mean that all of our problems from C have gone away. There are solutions using third-party libraries for scientific calculations and the like. But out of the box, floating point imprecision is still an issue. Meanwhile, there was one other problem in C that we ran into involving numbers, and that was this, integer overflow. Recall that an integer in C only took up, what, like 32 bits typically, which meant you could count as high as 4 billion, or maybe if you're doing positive and negatives, as high as 2 billion. After which, weird things would happen. The number would go to 0 or negative, or just it would overflow or wrap back around. Well, wonderfully in Python, they did at least address this, whereby you can count as high as you want. And Python will just use more and more and more and more bits and bytes to store really big numbers, so integer overflow is not a thing. With that said, Python is limited to how many digits it will show you on the screen at once as a string. But mathematically, your math will be correct now. So we've taken a couple steps forward, one step sideways. But indeed, we've solved some of our problems here. All right, questions now on any of these examples thus far? Question. All right, well, how about another problem that we encountered in C? Let's revisit it here in Python as well. So let me go ahead and on the left-hand side here, let me open up a file called, say, compare. Let's see. How about a file called compare3.c on the left? And let me go ahead and create a new file on the right called compare.py. Because recall that bad things happened when we needed to compare two values in C. So on the left here is a reminder of what we once did in C, whereby if we want to compare values, we can get an int in C, stored in x, a getInt in C, stored in y. We then have our familiar conditional logic here, just printing out if x is less than y or not. Well, we can certainly do the same thing ultimately in Python by using some fairly familiar syntax. And let's just demonstrate this one quickly. Let me go over here too. I'll do from CS50 import getInt, even though I could do this instead with the input function itself. X equals getInt, and I'll prompt the user for that. Y equals getInt, and I'll prompt the user for that. After that, recall that I can say without parentheses, if x is less than y, then print out, without the f, x is less than y. Then I can go ahead and say else if x is greater than y, I can print out quote unquote, x is greater than y. If you'd like to interject now, what did I screw up? Anyone? Yeah. elif, right? So elif x is greater than y, else, this part's the same, print x is equal to y. So there's not all that much there's no new logic going on here, but at least syntactically it's a little cleaner. Indeed, this program's only 11 lines long, albeit without any comments. Let me go ahead and run Python of compare.py. Let's see, is 1 less than 2? Indeed. Let's run it again. Is 2 less than 1? No, it's greater than. And let's lastly type in 1 and 1 twice. X is equal to y. So we've got a pretty side-by-side one-to-one conversion here. Let's do something a little more interesting than in C. How about I open instead something where we actually compared for a purpose? So if I open up from earlier in the course, how about agree.c, which prompt the user to agree to something or not. And let me code up a new version here called agree.py. And I'll do this on the right-hand side with agree.py. But on agree.c on the left, notice that this is how we did this sort of yes-no thing in C. We compared C, a character, equal to single quotes y, or equal to single quotes little y. And then the same thing for n. Now in Python, this one's actually going to be a little bit different here. Let me go ahead and in the Python version of this, let me do something like this. We'll use getString. Well, actually, no, we'll just use input in this case. So let's do s equals input, and we'll ask the user the same thing. Do you agree? Question mark. Then let's go ahead and say if s equals, how about y? How do I do this? Well, a few things. Turns out I'm going to do this. S equals little y. Then I'm going to go ahead and print out agreed. And if s equals capital N or s equals lowercase n, I'm going to go ahead and print out not agreed. And I claim for the moment that this is identical now to the program on the right, the program on the left in C. But what's different? So we're still doing the same kind of logic, these equals for comparing for equality. But notice that nicely enough, Python got rid of the 2 vertical bars, and it's just literally the word or. If you recall seeing ampersand to express a logical and in C, you can just write literally the word and. And so here's a hint of why Python tends to be pretty popular. People just like that it's a little closer to English. There's a little less of the cryptic syntax here. Now, this is correct, as this code will now work. But I've also used double quotes instead of single quotes. And I also omitted a few minutes ago from my list of data types in Python the word char. In Python, there are no chars. There are no individual characters. If you want to manipulate an individual character, you use a string, that is to say a str, of size 1. Now, in Python, you can use single quotes or double quotes. I'm deliberately using double quotes everywhere just for consistency with how we treat strings in C. It's pretty common, though, to use single quotes instead, if only because on most keyboards you don't have to hold the Shift key anymore. I mean, humans have really started to optimize just how quickly they want to be able to code. So using a single quote tends to be pretty popular in Python and other languages as well. They are fundamentally the same, single or double, unlike in C where they have meaning. So this is correct, I claim. And in fact, let me run this real quick. I'll open up my terminal window here. Let me get rid of the version in C and run python of agree.py, and I'll type in y. OK, I'll run it again and type in little y, and I'll stipulate it's going to work for no as well. But this isn't necessarily the only way we can do this. There are other ways to implement the same idea. And in fact, I can go about doing this instead. Let me go back up to my code here. And we saw a hint of this earlier. We know that lists exist in Python, and you can create them just by using square brackets. So what if I simplify the code a little bit and just say if s is in the following list of values, capital Y or lowercase y? It's not all that different logically, but it's a little tighter. It's a little more compact. So if s is in capital N or lowercase n, I can express that same idea too. So here again, it's just getting a little more pleasant to write code. There's less like hitting of the keyboard. You can express yourself a little more succinctly. And using the keyword in, Python will figure out how to search the entire list for whatever the value of s is. And if it finds it, it will return true automatically, else it will return false. So if I run agree.py again and type in capital Y or lowercase y, that still now works. Well, I can tighten this up further if I want to add more features. Well, what if I want to support not just y, big Y and little y, but how about yes, or in case the user's yelling, or someone who isn't good with caps lock types in yes. Wait a minute, but it could be weird. Like, do we want to support this or this? I mean, this just gets really tedious quickly, combinatorically, if you consider all of these possible permutations. What would be smarter than doing something like this if you want to just be able to tolerate yes in any form of capitalization? Like, logically, what would be nice?
Maybe whatever the input is, you just transfer it over to all lowercase or all uppercase and then redo it.
Exactly. Super common paradigm. Why don't we just force the user's input to all lowercase or all uppercase? Doesn't matter so long as we're self-consistent, and just compare against all uppercase or all lowercase. And that will get rid of all of the possible permutations otherwise. Now, in C, we might have done something like this. We might have simplified this whole list and just said, let's say we'll do, how about lowercase? So y or yes, and we'll just leave it at that. But we need to force now s to lowercase. Well, in C, we would have used the C-type library. We would have done like toLower and called that function, passing it in, although not really, because in C-type, those operate on individual characters or chars, not whole strings. We actually didn't see a function that could convert a whole string in C to lowercase. But in Python, we're going to benefit from some other feature as well. It turns out that Python supports what's called object-oriented programming. And we're only going to scratch the surface of this in CS50. But if you take a higher level course in programming or CS, you'll explore this as a different paradigm. Up until now in C, we've been focusing on what's called really procedural programming. You write procedures. You write functions, top to bottom, left to right. And when you want to change some value, we were in the habit of using a procedure. That is a function. You would pass something, like a variable, into a function, like toUpper or toLower, and it would do its thing and hand you back a value. Well, it turns out that it would be nicer, programming-wise, if some data types just had built-in functionality. Like, why do we have our variables over here and all of our helper functions, like toUpper and toLower over here, such that we constantly have to pass one into the other? It would be nice to sort of bake into our data types some built-in functionality so that you can change variables using their own default built-in functionality. And so object-oriented programming, otherwise known as OOP, is a technique whereby certain types of values, like a string, aka str, not only have properties inside of them, attributes, just like a struct in C, your data can also have functions built into them as well. So whereas in C, which is not object-oriented, you have structs, and structs can only store data, like a name and a number when implementing a person, in Python, you can, for instance, have not just a structure, otherwise known as a class, storing a name and a number. You can have a function like call that person or email that person or actual verbs or actions associated with that piece of data. Now, in the context of strings, it turns out that strings come with a lot of useful functionality. And in fact, at this URL here, which is in docs.python.org, which is the official documentation for Python, you'll see a whole list of methods, that is, functions that come with strings that you can actually use to modify their values. And what I mean by this is the following. If we go through the documentation, poke around, it turns out that strings come with a function called lower. And if you want to use that function, you just have to use slightly different syntax than in C. You do not do toLower, and you do not say, as I just did, lower, because this function is built into S itself. And just like in C, when you want to go inside of a variable, like a structure, and access a piece of data inside of it, like name or number, when you also have functions built into data types, aka methods. A method is just a function that is built into a piece of data. You can do s dot lower, open paren, close paren in this case. And I can do this down here as well. If s dot lower in quote unquote n or no, the whole thing, I can force this whole thing to lowercase. So the only difference here now is in object-oriented programming, instead of constantly passing a value into a function, you just access a function that's inside of the value. It just works because of how the language itself is defined. And the only way you know whether these functions exist is the documentation, a class, a book, a website, or the like. Questions now on this technique? All right, I claim this is correct. Now, even though you've never programmed, most of you, in Python before, not super well designed. There's a subtle inefficiency now on lines 3 and 5 together. What's dumb about how I've used lower, might you think? Yeah? Yeah, if you're going to use the same function twice and ask the same question, expecting the same answer, why are you calling the function itself twice? Maybe we should just store the result in a variable. So we could do this in a couple of different ways. We, for instance, could go up here and create another variable called t and set that equal to s.lower. And then we could just change this to be t here. But honestly, I don't think we technically need another variable altogether here. I could just do something like this. Let's change the value of s to be the lowercase version thereof. And so now I can quite simply refer to s again and again like this, reusing that same value. Now, to be sure, I have now just lost the user's original input. And if I care about that, if they typed in all caps, I have no idea anymore. So maybe I do want to use a separate variable altogether. But a takeaway here, too, is that strings in Python are technically what we'll call immutable. That is, they cannot be changed. This was not true in C. Once we gave you arrays in week 2 or memory in week 4, you could go to town on a string and change any of the characters you want, uppercasing, lowercasing, changing it, shortening it, and so forth. But in this case, this returns a copy of s forced to lowercase, it doesn't change the original string that is the memory, the bytes in the computer's memory. When you assign it back to s, you're essentially forgetting about the old version of s. But because Python does memory management for you, there's no malloc, there's no free, Python automatically frees up the original bytes, like YES, and hands them back to the operating system for you. All right, questions now on this technique. Questions on this. In general, I'll call out the Python documentation will start to be your friend, because in class we'll only scratch the surface with some of these things. But in docs.python.org, for instance, there's a whole reference of all of the built-in functions that come with the language, as well as, for instance, those with the string. All right, well, let me go ahead and, before we take a break, let's go ahead and create something a little familiar too, based on our weeks here in C. Let me propose that we revisit those examples involving some meows. So for instance, when we had our cat meow back in the first week and then second in C, we did something that was a little stupid at first, whereby we created a file, as I'll do here, this time called meow.py. And if I want a cat to meow 3 times, I could run it once like this, little copy paste, and now Python of meow.py, and I'm done. Now, we've visited this example like 2 times at least now in Scratch and in C. It's correct, I'll stipulate, but what's obviously poorly designed? What's the fault here? Yeah. It should just be a loop, right? Like, why type it 3 times? Literally copying and pasting is almost always a bad thing, except in C when you have the function prototypes that you need to borrow. But in this case, this is just inefficient. So what could we do better here in Python? Well, in Python, we could probably change this in a few different ways. We could borrow some of the syntax we proposed in slide form earlier, like give me a variable called I, set it to 0, no semicolon. While I is less than 3, if I want to do this 3 times, I can go ahead and print out meow, and then I can do I plus equals 1. And I think this would do the trick, Python of meow.py, and we're back in business already. Well, if I wanted to change this to a for loop, well, in Python, it would be a little tighter, but this would not be the best approach. So for I in 0, 1, 2, I could just do print meow like this, and that too would get the job done. But to our discussion earlier, this would get stupid pretty quickly if you had to keep enumerating all of these values. Like, what did we introduce instead? The range function, exactly. So that hands me back way more efficiently just the values I want, indeed 1 at a time. So even this, if I run it a third or fourth time, we've got the same result. But now let's transition to where we went with this back in the day. How can we start to modularize this? Like, just like it would be nice, I claimed, if MIT had given us a meow function, wouldn't it be nice if, like, Python had given us a meow function? Maybe less compelling in Python, but how can I build my own function? Well, I did this briefly with the spell checker earlier, but let me go ahead and propose that we could implement now our own version of this in Python as follows. Let me go ahead and start fresh here and use the keyword def. So this did not exist in C. You had the return value, the function name, the arguments. In Python, you literally say def to define a function. You give it a name like meow. And now I'm going to go ahead and in this function just print out meow. And this lets me change it to anything else I want in the future. But for now, it's an abstraction. And in fact, I can move it out of sight, out of mind. Just going to hit enter a bunch of times to pretend like now it exists, but I don't care how it is implemented. And up here now I can do something like this. For I in range of 3, let me go ahead and not print meow anymore. Let me just call meow, and tightening up my code further. But I think, let's see, Python of meow.py, this is, I think, going to be the first time it does not work correctly. OK, so here we have, sadly, our first Python error. And let's see. The syntax is going to be different from C, or Clang's output. Traceback is like the term of art here. This is like a trace back of all of the lines of code that were just executed, or really functions you called. The file name is uninteresting. This is like my code space specifically, but the file name is important here, meow.py. Line 2 is the issue. OK, I didn't get very far before I screwed up. And then there's a name error. And you'll see in Python, there's typically these capitalized keywords that hint at what the issue is. It's something related to names of variables. Meow is not defined. All right, you're programming Python for the first time. You've screwed up. You're following some online tutorial. You're seeing this. Reason through it. Like, why might meow not be defined? What can we infer about Python? How to troubleshoot logically. Maybe. Is it because meow is defined after? You know, as smart as Python seems to be vis-a-vis C, they have some similar design characteristics. So let's try that. So let me scroll all the way back down to where I moved this earlier. Let me get rid of it way down there. I'll copy it to my clipboard. And let me just kind of hack something together. Let me just put it up here. And let's see if this works. So now let me clear my terminal, run Python of meow.py. OK. We're back in business. So that was actually really good intuition, good debugging technique to sort of reason through it. Now, this is kind of contradicting what I claimed back in week 1, which was that, you know, the main part of your program ideally should just be at the top of the file. Like, don't make me look for it. It's not a huge deal with like a 4-line program. But if you've got 40 lines, 400 lines, you don't want like the juicy part of your program to be way down here and all of these functions way up here. So it would be nice maybe if we actually have a main function. And so it actually turns out to be a convention in Python to define a main function. It's not a special function that's automatically called like in C. But humans realized, you know what, that was a pretty useful feature. Let me define a function called main. Let me indent these lines underneath it. Let me practice what I'm preaching, which is put the main code at the top of the file. And wonderfully in Python now, you do not need prototypes. There's none of that hackish copying and pasting of the return type, the name, and the arguments to a function like we needed in C. This is now OK instead, except for one minor detail. Let me go ahead and run Python of meow.py. Hopefully now I've solved this problem by having a main function, but now nothing has happened. All right, even if you've never programmed in Python before, what might explain this behavior? And how do I fix? Again, when you're off in the real world learning some new language, all you have is deductive logic to debug. Yeah?
I remember in C, we actually, even though we put functions underneath the main, we still had to call just the name of the function right above main so that main knew what the function was.
Right. So the solution, to be clear, in C was that we had to put the prototype up here. Otherwise, we'd get an error message. In this case, I'm actually not getting an error message. And indeed, I'll claim that you don't need the prototypes in Python. Just not necessary, because that was annoying, if nothing else. But what else might explain? Yeah, and back? Yeah, maybe you have to call main itself. If main is not some special status in Python, maybe just because it exists isn't enough. And indeed, if you want to call main, the new convention is actually going to be, as the very last line of your program typically, to literally call main. It's a little stupid looking, but you know, they made a design decision, and this is how now we work around it. Python of meow.py now. We're back in business. But now logically, why does this work the way it does? Well, in this case, top to bottom, line 1 is telling Python to define a function called main, and then define it as follows, lines 2 and 3. But it's not calling main yet. Line 6 is telling Python how to define a function called meow, but it's not calling these lines yet. Now, on line 10, you're telling Python call main. And at that point, Python has been trained, if you will, to know what main is on line 1, to know what meow is on line 6. And so it's now perfectly OK for main to be above meow, because you never called them yet. You defined, and then you called. And that's the logic behind this. Any questions now on the structure of this technique here? Now, let's do one more then. Recall that the last thing we did in Scratch and in Python, Scratch and in C, was to actually parameterize these same functions. So suppose that you don't want main to be responsible for the loop here. You instead want to very simply do something like meow 3 times and be done with it. Well, in Python, it's going to be similar in spirit to C. But again, we don't need to keep mentioning data types. If you want meow to take some argument, like a number, n, you can just specify n as the name of that argument. Or you could call it anything else, of course, that you want. You don't have to specify int or anything else. In your code now, inside of meow, you can do something like for I in, let's say, I definitely now can't do this, because like that would be weird to start the list and end it with n. So if I can come back over here, what's the solution? How can I do something n times? Yeah, using range. So range is nice because I can pass in now this variable n, and now I can meow, whoops, now I can print out, quote unquote, meow. So it's almost the same as in Scratch, almost the same as in C, but it's a little simpler. And if now I run meow.py, I'll have the ability now to do this here as well. All right, questions on any of this? Right now, we're sort of like taking this stroll through week 1. We're going to momentarily escalate things to look not only at some of these basics, but also other features like we saw with face recognition, with the speller or the like. Because of how many of us are here, we have a huge amount of candy out in the lobby. So why don't we go ahead and take a 10-minute break, and when we come back, we'll do even fancier, more powerful things with Python in 10. All right, so we are back. Among our goals now are to introduce a few more building blocks so that we can solve more interesting problems at the end, much like those that we began with. You'll recall from a few weeks ago, we played with this sort of two-dimensional Super Mario world, and we tried to print a vertical column of like 3 or more bricks. Well, let me propose that we use this as an opportunity to now tinker with some of Python's more useful, more user-friendly functionality as well. So let me code a file called mario.py, and let's just print out like that, the equivalent of that vertical column. So it's of height 3. Each one is a hash. So let's do for I in range of 3 initially, and let's just print out a single hash. And I think now Python of mario.py, voila, we're in business, printing out just that same pyramid there, or just that same column there. What if, though, we want to print a column of like some variable height where the user tells us how tall they want it to be? Well, let me go up here, for instance, and instead, how about we'll use, let's do this. How about from CS50 import, how about the getInt function as before? So it will deal with making sure the user gives us an integer. And now, in the past, whenever we wanted to get a number from a user, we've actually followed a certain paradigm. In fact, if I open up here, for instance, how about Mario 1.c from a while back, you might recall that we had code like this. And we specifically use the do while loop in C whenever we want to like get something from the user, maybe again and again and again until they cooperate, at which point we finally break out of the loop. So it turns out Python does have while loops, does have for loops, does not have do while loops. And yet pretty much any time you've gotten user input, you've probably used this paradigm. So it turns out that the Python equivalent of this is to do similar in spirit, but using only a while loop. And a common paradigm in Python, as I alluded earlier, is to actually deliberately induce an infinite loop, while true, capital T, and then do what you want to do, like get an int from the user and prompt them for the height, for instance, in question. And then, if you're sure that the user has given you what you want, like n is greater than 0, which is what I want in this case because I want a positive integer, otherwise there's nothing to print, you literally just break out of the loop. And so we could actually use this technique in C. It's just not really done in C. You could absolutely in C have done a while true loop with the parentheses, lowercase true. You could break out of it and so forth. But in Python, this is like the Python way. And this is actually a term of art. This way in Python is Pythonic. Like this is the way everyone does it, quote unquote. Doesn't mean you have to, but that's sort of the way like the cool Python programmers would implement an idea like this, trying to do something again and again and again until the user actually cooperates. But all we've done is take away the do while loop, but still logically we can implement the same idea. Now below this, let me go ahead and just print out for I in range of n this time, because I want it to be variable and not 3. I can go ahead and print out the hash. Let me go ahead and get rid of the C version here. Open my terminal window, and I'll run again Python of mario.py. I'll type in 3, and I get back those 3 hashes. But if I instead type in 4, I now get 4 hashes instead. So the takeaway here is quite simply that this would be the way, for instance, to actually get back a value in Python that is consistent with some parameter, like greater than 0. How about this? Let's actually practice what we preached a moment ago with our meowing examples and kind of factoring all this out. Let me go ahead and define a main function as before. Let me go ahead and assume for the moment that a getHeight function exists, which is not a thing in Python. I'm going to invent it in just a moment. And now I'm going to go ahead and do something like this. For I in the range of that height, well, let's go ahead and print out those hashes. So I'm assuming that getHeight exists. Let me go ahead and implement that abstraction. So define a function now called getHeight. It's not going to take any arguments in this design. While true, I can go ahead and do the same thing as before. Assign a variable n, the return value of getInt, prompting the user for that height. And then if n is greater than 0, I can go ahead and break. But if I break here, I logically, just like in C, end up executing below the loop in question, but there's nothing there. But if I want getHeight to return the height, what should I type here on line 14 logically? What do I want to return, to be clear? Yeah, so I actually want to return n. And here's another curiosity of Python vis-a-vis C. There doesn't seem to be an issue of scope anymore, right? In C, it was super important to not only declare your variables with the data types, you also had to be mindful of like where they exist inside of those curly braces. In Python, it turns out you can be a little looser with things, for better or for worse. And so on line 11, if I create a variable called n, it exists on line 11, 12, and even 13 outside of the while loop. So to be clear, in C with a while loop, we would have ordinarily had not a colon. We would have had the curly brace like here and over here. And a week ago, I would have claimed that in C, n does not exist outside of the while loop by nature of those curly braces. Even though the curly braces are gone, Python actually allows you to use a variable anytime after you have assigned it a value. So slightly more powerful as such. However, I can tighten this up a little bit. Logically, and this is true in C, I don't really need to break out of the loop by using break. Recall that or know that I can actually, once I'm ready to go, I can just return the value I care about even inside of the loop. And that will have the side effect of breaking me out of the loop and also breaking me out of and returning from the entire function. So nothing too new here in terms of C versus Python except for this issue of scope. And I indeed returned n at the bottom there just to make clear that n would still exist. So either of those are correct. Now I just have a Python program that I think is going to allow me to implement this same Mario idea. So let's run Python of Mario.py and OK, so nothing happened. Python of Mario.py. What did I do wrong? Yeah, I have to call main. So at the bottom of my code, I have to call main here. And this is a stylistic detail that's been subtle. Generally speaking, when you are writing in Python, there's not a CS50 style guide per se. There's actually a Python style guide that most people adhere to. And in this case, double blank lines between functions is the norm. I'm doing that deliberately, although it might otherwise not be obvious. But now that I've called main on line 16, let's run Mario.py once more. Aha. Now we get there. Now we see it. Type in 3, and I'm back in business, printing out the values there. Yeah. Sure, why do I need the if condition at all? Why can't I just return n here as by doing return n? Or if I really want to be succinct, I could technically just do this. The only reason I added the if condition is because if the user types in -1, -2, I wanted to prompt them again and again. That's all. But that would be totally acceptable too if you were OK with that result instead. Well, let me do one other thing here to point out why we are using getInt so frequently, this new training wheel, albeit temporarily. So let me go back to the way it was a moment ago. And let me propose now to take away getInt. I claimed earlier that if you're not using getInt, you can just use the input function itself from Python. But that always returns a string or a str. And so recall that you have to pass the output of the input function to an int, either on the same line or, if you prefer, on another line instead. But it turns out what I didn't do was show you what happens if you don't cooperate with the user, with the program. So if I run Python of Mario.py now, works great, even without the getInt function. And I can do it with 4. Still works great. But let me clear my terminal and be difficult now as the user and type in cat for the height instead. Enter. Now we see one of those tracebacks again. This one is different. This isn't a name error, but apparently a value error. And if I kind of ignore the stuff I don't understand, I can see invalid literal for int with base 10 cat. That's a super cryptic way of saying that cat is not a number in decimal notation. And so I would seem to have to somehow handle this case. And if you want to be more curious, you'll see that this is indeed a trace back. And C tends to do this too, or the debugger would do this for you too. You can see all of the functions that have been called to get you to this point. So apparently my problem is initially in line 14. But line 14, if I keep scrolling, is uninteresting. It's main. But line 14 leads me to execute line 2, which is indeed in main. That leads me to execute line 9, which is in get height. And so, OK, here's the issue. So the closest line number to the error message is the one that probably reveals the most. Line 9 is where my issue is. So I can't just blindly ask the user for input and then convert it to an int if they're not going to give me an int. Now, how do we deal with this? Well, back in problem set 2, you might recall validating that the user typed in a number and using a for loop and the like. Well, it turns out there's a better way to do this in Python, and the semantics are kind of there. If you want to try to convert something to a number that might not actually be a number, turns out Python and certain other languages literally have a keyword called try. And if only this existed for the past few weeks, I know. But like, you can try to do the following with your code. What do I want to try to do? Well, I want to try to execute those few lines, except if there's an error. So I can say except if there's a value error, specifically the one I screwed up and created a moment ago. And if there is a value error, I can print out an informative message to the user like not an integer or anything else. And what's happening here now is literally this operative word try. Python is going to try to get input and try to convert it to an int. And it's going to try to check if it's greater than 0 and then try to return it. Why? All of 3 of those lines are indented underneath the try block. Except if something goes wrong, specifically a value error happens, then it prints this. But it doesn't return anything. And because I'm in a loop, that means it's going to do it again and again and again until the human actually cooperates and gives me an actual number. And so this, too, is what the world would call Pythonic. In Python, you don't necessarily rigorously try to validate the user's input, make sure they haven't screwed up. You honestly take a more lackadaisical approach and just try to do something, but catch an error if it happens. So catch is also a term of art, even though it's not a keyword here. Except if something happens, you handle it. So you try and you handle it. You sort of best effort programming, if you will. But this is baked into the mindset of the Python programming community. So now if I do Python of Mario.py and I cooperate, works great as before. Try and succeed. 3 works, 4 works. If, though, I try and fail by typing in cat, it doesn't crash, per se. It doesn't show me an error. It shows me something more user-friendly, like not an integer. And then I can try again with dog. Not an integer. I can try again with 5. And now it works. So we won't generally have you write much in the way of these try except blocks, only because they get a little sophisticated quickly. But that is to reveal what the getInt function is doing. This is why we give you the training wheels, so that when you want to get an int, you don't have to jump through all these annoying hoops to do so. But that's all the library is really doing for you, is just try and accept. You won't be left with any training wheels ultimately. Questions now on getting input and trying in this way? Anything at all? Yeah? Say that, oh, could you put the condition outside of the try block? Short answer, yes. And in fact, I struggled with this last night when tweaking this example to show the simplest version. I will disclaim that really, I should only be trying, literally, to do the fragile part. And then down here, I should be really doing what you're proposing, which is do the condition out here. The problem is, though, that logically, this gets messy quickly, right? Because except if there's a value error, I want to print out not an integer. I can't compare n against 0 then, because n doesn't exist because there was an error. So it turns out, and I'll show you this. This is now the advanced version of Python. There's actually an else keyword you can use in Python that does not accompany if or elif. It accompanies try and except, which I think is weirdly confusing. A different word would have been better. But if you really prefer, I could have done this instead. And this is one of these design things where like reasonable people will disagree. Generally speaking, you should only try to do the one line that might very well fail. But honestly, this looks kind of stupid now. It's just unnecessarily complicated. And so my own preference was actually the original, which was, yeah, I'm trying a few extra lines that really aren't going to fail mathematically, but it's just tighter. It's cleaner this way. And here's, again, the sort of like, arguments you'll start to make yourself as you get more comfortable with programming. You'll have an opinion. You'll disagree with someone. And so long as you can back your argument up, it's pretty reasonable, probably. All right, so how about we now take away some piece of magic that's been here for a while. Let me go ahead and delete all of this here. And let me propose that we revisit Not that vertical column and the exceptions that might result from getting input, but these like horizontal question marks that we saw a while ago. So I want all of those question marks on the same line. And yet I worry we're about to see a challenge here because print up until now has been putting new lines everywhere automatically, even without those \n's. Well, let me propose that we do this. For I in the range of 4, if I want 4 question marks, let me just print 4 question marks. Unfortunately, I don't think this is correct yet. Let me run Python of Mario.py. And of course, this gives me a column instead of the row of question marks that I want. So how do we do this? Well, it turns out if you read the documentation for the print function, it turns out that print, not surprisingly perhaps, takes a lot of different arguments as well. And in fact, if you go to the documentation for it, you'll see that it takes not just positional arguments, that is from left to right, separated by commas. It turns out Python supports a fancier feature with arguments where you can pass the names of arguments to functions too. So what do I mean by this? If I go back to VS Code here, and I've read the documentation, it turns out that yes, as before, you can pass multiple arguments to Python like this, like hello, comma, David, comma, Malin. That will just automatically concatenate all 3 of those positional arguments together. They're positional in the sense that they literally flow from left to right, separated by commas. But if you don't want to just pass in values like that, you want to actually print out, as I did before, a question mark, but you want to override the default behavior of print by changing the line ending, you can actually do this. You can use the name of an argument that you know exists from the documentation and set it equal to some alternative value. And in fact, even though this looks cryptic, this is how I would override the end of each line to be quote unquote, that is nothing. Because if you read the documentation, the default value for this end argument, does someone want to guess, is \n. So if you read the documentation, you'll see that \n is the implied default for this end argument. And so if you want to change it, you just say end equals something else. And so here, I can change it to nothing and now rerun Python of Mario.py. And now they're all on the same line. Now, it looks a little stupid because I made that sort of week 1 mistake where I still need to move the cursor to the next line. That's just a different problem. I'm just going to go over here and print nothing. I don't even need to print \n, because if print automatically gives you a \n, just call print with nothing, and you'll get that for free. So let me rerun Python of Mario.py, and now it looks a little prettier at the prompt. And to be super clear as to what's going on, suppose I want to sort of make an exclamation here. I could change the \n default to like an exclamation point just for kicks. And if I run Python of Mario.py again, now I get this sort of exclamation with question marks and exclamation points as well. So that's all that's going on here. And this is what's called a named argument. It literally has a name that you can specify when calling it in. And it's different from positional in that you're literally using the name. Let me propose something else, though. And this is why people kind of like Python. There's just kind of cool ways to do things. That's kind of a, it's a 3-line verbose way of printing out 4 question marks. I could certainly take the, shortcut and just do this, but that's not really that interesting for anyone, especially if I want to do it a variable number of times. But Python does let you do this. If you want to multiply a character some number of times, not only can you use plus for concatenation, you can use star or an asterisk for multiplication, if you will. That is concatenation again and again and again. So if I just print out quote unquote question mark times 4, that's actually going to be the tightest way, the most succinct way I can print 4 question marks instead. And if I don't use 4, I use n, where I get n from the user. Bang, like now I've gotten rid of the for loop entirely, and I'm using the star operator to manipulate it instead. And to be super clear here, insofar as Python does not have malloc or free or memory management that you have to do, guess what Python also doesn't have? Anything on your minds the past couple of weeks? Doesn't have pointers. Yeah, so Python does not have pointers, which just means that all of that happens for you automatically underneath the hood, again, by way of code that someone else wrote. How about one more throwback with Mario? We talked about in week 1 this sort of 2-dimensional structure where it's like I claim like 3 by 3, a grid of bricks, if you will. Well, how can we do this in Python? We can do this in a couple of ways now. Let me go back to my mario.py, and let me do something like for I in range of, we'll just do 3, even though I know now I could use getInt, or I could use input and int. And if I want to do something 2-dimensionally, just like in C, you can nest your for loops. So maybe I could do for j in range of 3. And then in here, I could print out a hash symbol. And then let's see if that gives me 9 total. So if I've got a nested loop like this, Python of mario.py hopefully gives me a grid. No, it gave me a column of 9. Why, logically? Even though I've got my row and my columns. Yeah. Yeah, the line ending. So in my row, I can't let print just keep adding new line, adding new line. So I just have to override this here. And let me not screw up like before. Let me print 1 at the end of the whole row just to move the cursor down. And I think now together, now we've got our 3 by 3. Of course, we could tighten this up further. Like if I don't like the nested loop, I probably could go in here and just print out, for instance, a brick times 3, or I could change the 3 to a variable if I've gotten it from the user. So I can tighten this up further. So again, just different ways to solve the same problem. And again, sort of evidence of why a lot of people like Python. There's just some more pleasant ways to solve problems without getting into the weeds constantly of doing things like with for loops and while loops endlessly. All right, well, how about some other building blocks? Lists are going to be so incredibly useful in Python, just as arrays were in C. But arrays are annoying because you have to manage the memory yourself. You have to know in advance how big they are, or you have to use pointers and malloc or realloc to resize them. Like, oh my god, like the past 2 weeks have been painful in that sense. But Python does this all for free for you. In fact, there's a whole bunch of functions that come with Python that involve lists, and they'll allow us ultimately to do things again and again and again within the same data structure. And for instance, we'll be able to get the length of a list. You don't have to remember it yourself in a variable. You can just ask Python how many elements are in this list. And with this, I think we can solve some old problems too. So let me go back here to VS Code. Let me close Mario and give us a new program called scores.py. And rather than show the C and the Python now, let's just focus on Python. And in scores.c, way back when, we just averaged like 3 test scores or something like that, 72, 73, and 33 a few weeks ago. So if I want to create a list in this Python version of 72, 73, 33, I just use my square bracket notation. C let you use curly braces if you know the values in advance, but Python's just this. And now if I want to compute the average, in C, recall, I did something with a loop. I added all the values together. I then divided by the total number of values, just like you would in grade school, and that gave me the average. Well, Python comes with a lot of super handy functions, not just length, but others as well. And so in fact, if you want to compute the average, you can take the sum of all of those scores and divide it by the length of all of those scores. So Python comes with length, comes with sum. You can just pass in a whole list of any size and let it deal with that problem for you. So if I want to now print out this average, I can print out average colon, and then I'll plug in my average string for a variable for interpolation. Let me make this an f string so that it gets formatted. And let me just run Python of scores.py. And there's my average. It's sort of rounding weird because we're still vulnerable to some floating point imprecision. But at least I didn't need loops, and I didn't have to write all this darn code just to do something that, you know, Excel and Google Spreadsheets can just do like that. Well, Python is closer to those kinds of tools, but more powerful in that you can manipulate the data yourself. How about, though, if I want to get a bunch of scores manually from the user and then sum them together? Well, let's combine a few ideas here. How about this? First, let me go ahead and import the CS50 getInt function from the CS50 library, just so we don't have to deal with try and accept or all of that. And let me go ahead and give myself an empty list. And this is powerful. In C, there's no point to an empty array, because if you create an empty array with square bracket notation, like, it's not useful for anything. But in Python, you can create it empty because Python will grow and shrink the list for you automatically as you add things to it. So if I want to get 3 scores from the user, I could do something like this. For I in range of 3. And then I can grab a variable called score or anything. I could call getInt, prompt the human for the score that they want to type in. And then once they do, I can do this, thinking back to our object-oriented programming capability now. I could do scores dot append, and I can append that score to it. And you would only know this from having read the documentation, heard it in class in a book or whatnot. But it turns out that just like strings have functions like lower built into them, lists have functions like append built into them that just literally appends to the end of the list for you. And Python will grow or shrink it as needed. No more malloc or realloc or the like. So this just appends to the scores array, the scores list, that score, and then again and again and again. So the array starts at, the list starts at size 0, then grows to 1, then 2, then 3, without you having to do anything else. And so now down here, I can compute an average with the sum of those scores divided by the length of the total number of scores. And to be clear, length is the total number of elements in the list. Doesn't matter how big the values themselves are. Now I can go ahead and print out an f string with something like average, colon average in curly braces. And if I run python of scores.py, I'll type in, just for the sake of discussion, the 3 values. I still get the same answer. But that would have been painful to do in C unless you committed in advance to a fixed size array, which we already decided weeks ago was annoying, or you grew it dynamically using malloc or realloc or the like. All right, what else can I do? Well, there's some nice things you might as well know exist. Instead of scores.append, you can do slight fanciness like this. Like if you want to append something to a list, you can actually do plus equals and then put that thing in a temporary list of its own and just use what is essentially concatenation, but not concatenation of strings, but concatenation of lists. So this new line 6 appends to the scores list this tiny little list I'm temporarily creating with just the current new score. So just another piece of syntax that's worth seeing that allows you to do something like that as well. All right, well, how about we go back to strings for a moment? And all of these examples, as always, are on the course's website afterward. Suppose we want to do something like converting characters to uppercase. Well, to be clear, I could do something like this. Let me create a program called uppercase.py. Let me prompt the user for a before string, as by using the input function or getString, which is almost the same. And I'll prompt the user for a string beforehand. Then let me go ahead and print out, how about the keyword after, and then end the new line with nothing, just so that I can see before on one line and after on the next line. And then let me do this. And here's where Python gets pleasant too with loops. For C in before, print c.upper end equals quote unquote, and then I'll print this here. All right, that was fast, but let's try to infer what's going on. So line 1 just gets input from the user, stores it in a variable called before. Line 2 literally just prints after, but doesn't move the new line, the cursor to the next line. What it then does is this. And in C, this was a little more annoying. You needed a for loop with I. You needed array notation with the square brackets. But Python, if you say for variable in string, so for C, for character in string, Python's going to automatically assign C to the first letter that the user types in. Then on the next iteration, the second letter, the third letter, and the fourth. So you don't need any square bracket notation. You just use C, and Python will do it for you and just hand you back one at a time each of the letters that the user has typed in. So if I go back over here and I run, for instance, python of uppercase.py, and I'll type in, how about David in all lowercase and hit enter, you'll now see that it's all uppercase instead by iterating over it, indeed one character at a time. But we already know, thanks to object-oriented programming, strings themselves have the functionality built in to not just uppercase single characters, but the whole string. So honestly, this was a bit of a silly exercise. I don't need to use a loop anymore like in C. And so some of the habits you've only just developed in recent weeks, it's time to start breaking them when they're not necessary. I can create a variable called after, set it equal to before.upper, which indeed exists, just like .lower exists. And then what I can go ahead and print out is, for instance, let's get rid of this print line here and do it at the end, after, and print the value of that variable. So now if I rerun uppercase.py, type in David in all lowercase, I can just uppercase the whole thing all at once, because again, in Python, you don't have to operate on characters individually. Questions on any of these tricks up until now? No? All right, how about a few other techniques that we saw in C that we'll bring back now in Python? So it turns out in Python, there are other libraries you can use too that unlock even more functionality. So in C, if you wanted command line arguments, you just change the signature for main to be void, instead of void, to be int argc, comma, string argv, open brackets for an array, or char star eventually. Well, it turns out in Python that if you want to access command line arguments, it's a little simpler, but they're tucked away in a library, otherwise known as a module called sys, the sys or system module. Now, this is similar in spirit to the CS50 library in that it's got a bunch of functionality built in, but this one comes with Python itself. So if I want to create a program like greet.py in VS Code here, let me go ahead and do this. From the sys library, let's import argv. And that's just a thing that exists. It's not built into main because there is no main per se anymore. So it's tucked away in that library. And now I can do something like this. If the length of argv equals 2, well, let's go ahead and print out something friendly like hello, comma, argv bracket 1, and then close quotes. Else, if the length of argv is not equal to 2, let's just go ahead and print out hello world. Now, at a glance, this might look a little cryptic, but it's identical to what we did a few weeks ago. When I run this Python of greet.py with no arguments, it just says hello world. But if I instead add a command line argument, like my first name, and hit enter, now the length of argv is no longer 1. It's going to be 2. And so it prints out hello David instead. So the takeaway here is that whereas in C, argv technically contained the name of your program, like /hello or /greet, and then everything the human typed. Python's a little different in that because we're using the interpreter in this way, technically when you run Python of greet.py, the length of argv is only 1. It contains only greet.py. So the name of the file, it does not unnecessarily contain Python itself, because what's the point of that being there omnipresently? It does contain the number of words that the human typed after Python itself. So argv is length 1 here, argv is length 2 here, and that's why when it did equal 2, I saw hello David instead of the default hello world. So same ability to access command line arguments, add these kinds of inputs to your functions, but you have to unlock it by way of using argv instead in this way. If you want to see all of the words, you could do something like this. Just as if we combine ideas here, for I in range of, how about length of argv, then I can do this, print argv bracket I. All right, a little cryptic. But line 3 is just a for loop, iterating over the range of length of argv. So if the human types in 2 words, the length of argv will be 2. So this is just a way of saying iterate over all of the words in argv, printing them one at a time. So Python of greet.py, enter, just prints out the name of the program. Python of greet.py with David prints out greet.py and then David. I can keep running it, though, with more words, and they'll each get printed one at a time. But what's nice, too, about Python, and this is the point of this exercise, honestly, this looks pretty cryptic. This is not very pleasant to look at. If you just want to iterate over every word in a list, which argv is, watch what I can do. I can do for arg, or any variable name, in argv. Let me just now print out that argument. I could keep calling it I, but I seems weird when it's not a number, so I'm changing to arg as a word instead. If I now do Python of greet.py, it does this. If I do Python of greet.py David, it does that again. David Malin, it does that again. So this is, again, why Python is just very appealing. You want to do something this many times, iterate over a list, just say it. And it reads a little more like English. And there's even other fanciness, too, if I may. It's a little stupid that I keep seeing the name of the program, greet.py. So it'd be nice if I could remove that. Python also supports what are called slices of arrays. Slices of lists. Even I get the terminology confused. If argv is a list, then it's going to print out everything in it. But if I want a slice of it that starts at location 1 all the way to the end, you can use this funky syntax in between the square brackets, which we've not seen yet, that's going to start at item 1 and go all the way to the end. And so this is a nice, clever way of slicing off, if you will, the very first element, because now when I run greet.py David Malin, I should only see David and Malin. If I only want one element, I could do 1 to 2. If I want all of them, I could do 0 onward. I could give myself just one of them in this way, so you can play with the start value and the end value in this way to sort of slice and dice these lists in different ways. That would have been a pain in C just because we didn't really have the built-in support for manipulating arrays as cleanly as this. All right, just so you've seen it too, though this one is less exciting to see live, if I go ahead and create a quick program here, it turns out there's something else in the sys library, the ability to exit programs, either exiting with status code 1 or 0, as we've been doing anytime something goes right or wrong. So for instance, let me whip up a quick program that just says if the length of sys.argv does not equal 2, then let's yell at the user and say, you're missing a command line argument. Otherwise, command line argument. And let's then return sys.exit1. Else, let's go ahead and logically just say print a formatted string that says hello as before, sys.argv1. Now, things look different all of a sudden, but I'm doing something deliberately. First, let's see what this does. So on line 1, I'm importing not argv specifically. I'm importing the whole sys library, and we'll see why in a second. Well, it turns out that this the sys library has not only the argv list, it also has a function called exit, which I'd like to be able to use as well. So it turns out that if you import a whole library in this way, that's fine, but you have to refer to the things inside of it by using that same library's name and a dot to sort of namespace it, so to speak. So here I'm just saying if the user does not type in 2 words, yell at them with missing command line argument and then exit with 1. Just like in C, when you do exit 1, just means something went wrong. Otherwise, print out hello to this. And this is starting to look cryptic, but it's just a combination of ideas. The curly braces means interpolate this value, plug it in here. Sys.argv is just the verbose way of saying go into the sys library and get the argv variable therein. And bracket 1, of course, just like arrays in C, is just the second element at the prompt. So when I run this version now, Python of exit.py, with no arguments, I get yelled at in this way. If, however, I type in 2 arguments total, the name of the file and my own name, now I get greeted with hello, David. And it's the same idea before. This was a very low-level technique, but same thing here. If you do echo $? Enter, you'll see the exit code of your program. So if I do this incorrectly again, let me rerun it without my name, enter, I get yelled at. But if I do echo $? There's the secret one that's returned. Again, just to show you parity with C in this case. Questions now on any of these techniques here? All right, how about something that's a little more powerful too? We spent so much time in week 0 and 1 doing searching and then eventually sorting in week 3. Well, it turns out Python can help with some of this too. Let me go ahead and create a program called names.py that's just going to be an opportunity to maybe search over a whole bunch of names. Let me go ahead and import sys. And then just so I have access to exit. And let me go ahead and create a variable called names that's going to be a list with a whole bunch of names. How about here? Charlie and Fred and George and Ginny and Percy, and lastly, Ron. So a whole bunch of names here. And, you know, it'd be a little annoying to implement code that iterates over that from left to right in C, searching for one of those names. In fact, what name? Well, let's go ahead and ask the user to input the name that they want to search for so that we can tell them if the name is there or not. And we could do this similar to C in Python, doing something like this. So for n in names, where n is just a variable to iterate over each name, if how about the name I'm looking for equals the current name in the list, aka n, well, let's print out something friendly like found. And then let's do sys.exit0 to indicate that we found whoever that is. Otherwise, if we get all the way to the bottom here outside of this loop, let's just print not found, because if we haven't exited yet, and then let's just exit with 1. Just to be clear, I can continue importing all of sys, or I could do from sys import exit, and then I could get rid of sys dot everywhere else. But, you know, sometimes it's helpful to know exactly where functions came from. So this, too, is just a matter of style in this case. All right, so let's go ahead and run this. Python of names.py. And let's look for, like, Ron all the way at the end. You know, all right, he's found. And let's search for someone outside of the family here, like Hermione. Not found. OK, so it seems to be working in this way. But I've essentially implemented what algorithm? What algorithm would this seem to be? per lines 7 and 8 and 9 and 10. Yeah, so it's just linear search. It's a loop, even though the syntax is a little more succinct today, and it's just iterating over the whole thing. Well, honestly, we've seen an even more terse way to do this in Python, and this, again, is what makes it a more pleasant language sometimes. Why don't I just do this? Instead of iterating one at a time, why don't I just say this? Let me go ahead and change my condition to just be, how about if the name we're looking for is in the names list, we're done. We found it. Use the in preposition that we've seen a couple of times now that itself asks the question, is something in something else? And Python will take care of linear search for us. And it's going to work exactly the same. If I do Python of names.py, search for run, it's still going to find him. And it's still going to do it linearly in this case, but I don't have to write all of the lower level code myself in this case. Questions now on any of this? Code's just getting shorter and shorter. Now, what about, let's see, what else might we have here? How about this? It turns out, let's go ahead and implement that phone book that we started metaphorically with in the beginning of the course. Let's code up a program called phonebook.py. And in this case, let's go ahead and let's create a dictionary this time. Recall that a dictionary is a little something that implements something like this, like a 2-column table that's got keys and values, words and definitions, names and numbers. And let's focus on the last of those, names and numbers in this case. Well, I claimed earlier that Python has built-in support for dictionaries, dict objects that you can create with one line. I didn't need it for Speller because a set is sufficient when you only want one of the keys or the values, not both. But now I want some names and numbers. So it turns out in Python, you can create an empty dictionary by saying dict open parenthesis close, and that just gives you essentially a chart that looks like this with nothing in it. Or there's more succinct syntax. You can alternatively do this with 2 curly braces instead. And in fact, I've been using a shortcut all this time. When I had a list earlier where my variable was called scores, and I did this, that was actually the shorthand version of this. Hey, Python, give me an empty list. So there's different syntax for achieving the same goal. In this case, if I want a dictionary for people, I can either do this or, more commonly, just 2 curly braces like that. All right, well, what do I want to put in this? Well, let me actually put some things in this, and I'm going to just move my close curly brace to a new line. If I want to implement this idea of keys and values, the way you do this in Python is key, colon, value, comma, key, colon, value. So you'd implement it more in code. So for instance, if I want Carter to be the first key in my phone book, and I want his number to be +1 617 495 1000, I can put that as the corresponding value. The colon is in between. Both are strings or strs, so I've quoted both deliberately. If I want to add myself, I can put a comma. And then just to keep things pretty, I'm moving the cursor to the next line, but that's not strictly required aesthetically. It's just good style. And here I might do +1 949 468 2750. And now I have a dictionary that essentially has 2 rows here, Carter and his number, and David and his number as well. And if I kept adding to this chart would just get longer and longer. Suppose I want to search for one of our numbers. Well, let's prompt the user for the name for whose number you want to search by getting string. Or you know what? We don't need the CS50 library. Let's just use input and prompt the user for a name. And now we can use this super terse syntax and just say if name in people print the formatted string number, colon, and here we can do this, people bracket name. OK, so this is getting kind of cool, kind of quickly, kind of confusingly. So let me run this. Python of phonebook.py. Let's type in Carter, and indeed I see his number. Let's run it again with David, and I see my number here. So what's going on? Well, it turns out that a dictionary is very similar in spirit to a list. It's actually very similar in spirit to an array in C. But instead of being limited to keys that are numbers, like bracket 0, bracket 1, bracket 2, you can actually use words. And that's all I'm doing here on line 8. If I want to check for the name Carter, which is currently in this variable called name, I can index into my people dictionary using not a number, but using literally a string, the name Carter, or David, or anything else. To make this clear too, notice that I'm at the moment using this format string, which is adding some undue complexity. But I could clarify this perhaps further as this. I could give myself another variable called number, set it equal to the people dictionary, indexing into it using the current name. And now I can shorten this to make it clearer that all I'm doing is printing the value of that. And in fact, I can do this even more cryptically if this would be weird to do, but if I only ever want to show David's phone number and never Carter's, I can literally, quote unquote, index into the people dictionary, because now when I run this, even if I type Carter, I'm going to get back my number instead. But that's all that's happening if I undo that, because that's now a bug. But I index into it using the value of name. Dictionaries are just so wonderfully convenient because now you can associate anything with anything else, but not using numbers, but entire keywords instead. So here's how if in Speller we gave you not just words, but hundreds of thousands of definitions as well. You could essentially store them as this, and then when the human wants to look up a definition in a proper dictionary, not just for spell checking, you could index into the dictionary using square brackets and get back the definition in English as well. Questions on this? Yeah?
Is the way that this code does it, because I know you're saying that Python has functions already made for you, does the if preposition actually iterate through it, or through an array to find the value? Or because you're calling the value here, it must still find a way to go to location and find it?
A really good question. So to summarize, how is Python finding that name within that dictionary? This is where, honestly, Speller and pset5 is what Python's all about. So you are struggling with implementing your own spell checker and implementing your own hash table. And recall that per last week, the goal of a hash table is to ideally get constant time access, not something linear, which is slow, and even better than something logarithmic like log base 2 of n. So Python and the really smart people who invented it, they have written the code that does its best to give you constant time searches of dictionaries. And they're not always going to succeed, just as you in your own problem set probably going to have some collisions once in a while and start to have chains of linked lists of words. But this is where, again, you defer to someone else, someone smarter than you, someone with more time than you to solve these problems for you. And if you read Python's documentation, you'll see that it doesn't guarantee constant time, but it's going to ideally optimize the data structure for you to get as fast as possible. And of all of the data structures, like a dictionary, a hash table is really like the Swiss Army knife of computing, because it just lets you associate something with something else. And even though we keep focusing on names and numbers, that's a really powerful thing, because it's more powerful than lists and arrays, which are only numbers and something else. Now you can have any sorts of relationships instead. All right, let me show a few other examples before we culminate with some more powerful techniques in Python thanks to libraries. How about this problem we encountered in week 4, which was this? Let me code up a program called, again, compare.py here. But this time, compare two strings and not numbers. So let me, for instance, get one string from the user called s. Just for the sake of discussion, let me get another string from the user called t, so that we can actually do some comparison here. And if s equals t, let's go ahead and print out that they're the same. Else, let's go ahead and print out that they're different. So this is very similar to what we did in week 4. But in week 4, recall, we did this specifically because we had encountered a problem. For instance, if I run, what's going on? Input T. Come on. Oh, OK, wow, OK, long day. All right, if I run the proper command, python of compare.py, then let's go ahead and type in something like cat in all lowercase, cat in all lowercase, and they're the same. If, though, I do this again with dog and dog, they're the same. And of course, cat and dog, they're different. But does anyone recall from 2 weeks ago when I typed in my name twice, both identically capitalized, what did it say? That they were, in fact, different. And why was that? Like, why were two strings in C different, even though I typed literally the same thing? two different places in memory. So each string might look the same aesthetically, but of course was stored elsewhere in memory. And yet Python appears to be using the equality operator, equals equals, like you and I would expect as humans, actually comparing for us char by char in each of those strings for actual equality. So this is a feature of Python in that it's just easier to do. And why? Well, this derives from the reality that in Python there are no pointers anymore. There's no underlying memory management. It's not up to you now to worry about those lower level details. The language itself takes care of that for you. And so similarly, if I do this and don't ask the user for two strings, but just one, and then I do something like this, how about give myself a second variable t, set it equal to s.capitalize, which note is not the same as upper. Capitalize by design per Python's documentation will only capitalize the first letter for you. I can now print out, say, two f strings here, what the value of s is. And then let me print out with another f string what the value of t is. And recall that in C, this was a problem because if you capitalize s and store it in t, we accidentally capitalized both s and t. But in this case in Python, when I actually run this and type in cat in all lowercase, the original s is unchanged because when I use capitalize on line 3, this is indeed capitalizing s, but it's returning a copy of the result. It cannot change s itself because, again, for that technical term, s is immutable. Strings, once they exist, cannot be changed themselves, but you can return copies and modified, mutated copies of those same strings. So in short, all of those headaches we encountered in week 4 are now solved really in the way you might expect. And here's another one that we dwelled on in week 4 with the colored liquid in glasses. Let me code up a program called swap.py. And in swap.py, let me set x equal to 1, y equal to 2. And then let me just print out an f string here. So how about x is this, comma, y is that. And then let me do that twice just for the sake of demonstration. And in here, recall that we had to create a swap function, but then we had to pass it in by reference with the ampersand. And like, oh my God, like that was kind of peak complexity in C. Well, if you want to swap x and y in Python, you could do x comma y equals y comma x. And now Python of swap.py, and there we go. All of that's handled for you. It's sort of like a shell game without even a temporary variable in mind. So what more can we do here? How about a few final building blocks? And these related now to files from that week 4. Suppose that I want to save some names and numbers in like a CSV file, comma separated values, which is like a very lightweight spreadsheet. Well, first, let me create a phonebook.csv file that just has name, comma, number as like the first row there. But after that, I'm going to go ahead now and code up a phonebook.py program that actually allows me to add things to this phone book. So let me split my screen here so that we can see the old and the new. And down here in my code for phonebook.py, in this new and improved version, I'm going to actually import a whole other library, this one called CSV. And here too, especially for people in data science and the like, really like being able to manipulate files and data that might very well be stored in spreadsheets or CSVs, comma, separated values, which we saw briefly in week 4. In phonebook.py then, it suffices to just import CSV after reading the documentation therefore, because this is going to give me functionality in code related to CSV files. So here's how I might open a file in Python. I literally call open. It's not fopen now. It's just open. And I open this file called phonebook.csv. And just as in C, I'm going to open it in append mode. Not write, where it would change the whole thing. I want to append, new line at a time. After this, I want to get maybe, how about a name from the user? So let's prompt the user for some input for their name. And then let's prompt the user for a number as well using input, prompting for number. All right, and now this is a little cryptic, and you'd only know this from the documentation. But if you want to write rows to a CSV file that you can then view in Excel or the like, you can do this. Give me a variable called writer, but I could call it anything I want. Let me use a csv.writer function that comes with this CSV library, passing in the file. This is like saying, hey, Python, treat this open file as a CSV file so that things are separated with commas and nicely formatted in rows and columns. Now I'm going to do this. Use that writer to write a row. Well, what do I want to write? I want to write a short list, namely the current name and the current number, to that file. But I don't want to use fprintf and %s and all of that stuff that we might have had in the past. And now I just want to close the file. Let me reopen my terminal. Let me run Python of phonebook.py. And let me type in, how about David, and then +1 949 468 2750, and crossing my fingers, watching the actual CSV at top left, my code has just added me to the file. And if I were to run it again, for instance, with Carter and +1 617 495 1000, crossing my fingers again, we've updated the file. And it turns out there's code now via which I can even read that file, but I can first tighten this up just so you've seen it. It turns out in Python, it's so common to open files and close them. You know, humans make mistakes, and they often forget to close files, which might then end up using more memory than you intend. So you can alternatively do this in Python so that you don't have to worry about closing files. You can use this keyword instead. You can say with the opening of this file as a variable called file, do all of the following underneath. So I'm indenting most of my code. I'm using this new Python-specific keyword called with. And this is just a matter of saying, with the following opening of the file, do those next 4 lines of code, and then automatically close it for me at the end of the indentation. It's a minor optimization, but this, again, is sort of the Pythonic way to do things instead. How else might I do this too? Well, it turns out that the code I've written here, on line 9 especially, is a little fragile, right? If any human opens this spreadsheet, the CSV file in Excel, Google Spreadsheets, Apple Numbers, and maybe like moves the columns around just because maybe they're futzing, they save it, and they don't realize they've now changed my assumptions, I don't want to necessarily write name and number always in that order, because what if someone screws up and flips those 2 columns by literally dragging and dropping? So it turns out that instead of using a list here, we can use another feature of this library as follows. Instead of using a writer, there's something called a dictionary writer or dict writer that takes the same argument as input, the file that's opened. But now the one difference here is that you need to tell this dictionary writer that your field names are name and number. And let me close the CSV here. Name and number are the names of the fields, the columns in this CSV file. And when it comes time to write a new row, the syntax here is going to be a little uglier, but it's just a dictionary. The name I want to write to the dictionary is going to be whatever name the human typed in. The number that I want to write to the CSV file is going to be whatever the number the human typed in. But what's different now about this code is by simply using a dictionary writer here instead of the generic writer, now the columns can be in this order or any order. And the dictionary writer is going to figure out, based on the first line of text in that CSV, where to put name, where to put number. So if you flip them, no big deal. It's going to notice, oh, wait, the columns changed. And it's going to insert the columns correctly. So just, again, another more powerful feature that lets you focus on real work as opposed to actually getting tied up in the weeds of writing code like this otherwise. Questions on this one as well? But what we will do now is come full circle to some of the more sophisticated examples with which we began. And I'm going to go back over to my own Mac laptop here, where I've got my own terminal window up and running. And I was just going to introduce a couple of final libraries that really speak to just how powerful Python can be and how quickly you can get up and running. To be fair, can't necessarily do all of these things in the cloud, like in code spaces, because you need access to your own speakers or microphone or the like. So that's why I'm doing it on my own Mac here. But let me go ahead and open up a program called speech.py. And I'm not using VS Code here. I'm using a program called VI that's entirely terminal window based. But it's going to allow me, for instance, to import the Python text-to-speech version 3 library. I'm going to give myself a variable called engine that's going to be set equal to the Python text-to-speech 3 libraries init method, which is just going to initialize this library that relates to text-to-speech. I'm going to then use the engine's say function to say something like, how about hello, comma, world? And then as my last line, I'm going to say engine.run and wait, capitalized as such, to tell my program now to run that speech and wait until it's done. All right, I'm going to save this file. I'm going to run Python of speech.py, and I'm going to cross my fingers as always, and
hello, world.
All right, so now I have a program that's actually synthesizing speech using a library like this. How can I now modify this to be a little more interesting? Well, how about this? Let me go ahead and prompt the user for their name, like we've done several times here using Python's built-in name function. And now let me go ahead and use a format string in conjunction with this library, interpolating the value of name there. And at least if my name is somewhat phonetically pronounceable, let's go ahead and run python of speech.py, type in my name, and
hello, David.
OK, it's a sort of weird choice of inflection, but we're starting to synthesize voice, not unlike Siri or Google Assistant or Alexa or the like. Now we can maybe do something a little more advanced too. In addition to synthesizing speech in this way, we could synthesize, for instance, an actual graphic. Let me go ahead now and do something like this. Let me create a program called qr.py. I'm going to go ahead and import a library called OS, which gives you access to operating system related functionality in Python. I'm going to import a library I've pre-installed called QR code, which is a two-dimensional barcode that you might have seen in the real world. I'm going to go ahead and create an image variable using this QR code library's make function, which per its documentation takes a URL like one of CS50's own videos. So we'll do this with YouTube /XVFZO5PGG0. So hopefully that's the right lecture. And now we've got image.save, which is going to allow me to create a file called qr.ping. Think back now on problem set 4 and how painful it was to save files. We'll just use the save function now in Python and save this as a ping file, portable network graphic. And then lastly, let's just go ahead and open with the command open qr.ping on my Mac so that hopefully this just automatically opens. All right, I'm going to go ahead and just double check my syntax here so that I haven't made any mistakes. I'm going to go ahead and run python of qr.py, enter. That opens up this. Let me go ahead and zoom in. If you've got a phone handy and you'd like to scan this code here, whether in person or online, I apologize. You won't appreciate it. Amazing. OK. And lastly, let me go back into our speech example here, create a final ending here in our final moments. And how about we just say something like this was CS50, like this. Let's go ahead here, fix my capitalization just for tidiness, get rid of the name. And now with our final flourish and your introduction to Python equipped, here we go.
This was CS50.
All right, we'll see you next time. This is CS50, and this is already week 7. And this is the week where we'll continue where we left off with Python, introducing you to a bit more syntax and capabilities of the language so you can solve like interesting problems. But a lot of those problems increasingly are now going to involve data in some form. After all, if you think of most any website or mobile app or process nowadays that involves solving problems, it almost always involves some amount of data, and often data at scale, lots and lots of data. And so what we're going to see first today is that, yes, you can use Python to solve all the problems past that we've seen, and also some data-specific ones, but sometimes it's just going to be annoying. It's going to be a little painful. It's just going to be more work than you might like to just get to some answer. And so today we'll, too, introduce you to a new language called SQL, Structured Query Language. And this is a language that, rest assured, is actually much smaller, relatively speaking, than C and Python. It sort of does less, but it does it really well. And it's a language for querying databases, storing data in it, updating it, inserting it, deleting it, and so much more. And it's the kind of technology that's used nowadays in, indeed, web apps and mobile apps, data science, analytics, and so much more. It's really good at storing lots and lots of data. Now, this is yet another language. And believe it or not, next week, we'll introduce you to 3 more languages, HTML and CSS, which are not technically programming languages. They're all about aesthetics and markup of information, but also JavaScript, which is, in fact, a programming language. But the goals here in CS50 really are going to be to empower you to program more generally. And indeed, when you're out there in the real world, some years from now, invariably, there's going to be some new, other popular language out there. And hopefully, in this week and next week and beyond, among the goals is not just to teach you these languages specifically, but again, like how to teach yourself the future languages that we've not even heard about just yet. So with that said, let's begin with a survey of sorts. If you go to this URL on your phone or laptop, cs50.ly/favorites, a very simple Google form awaits you that's just going to ask you a couple of multiple choice questions. So go to cs50.ly/favorites, and that should lead you to a Google form that looks a little something like this, asking you first, as of now in week 7, what is your favorite language among those options here? And then further down, one more question. If you think back on problem sets 0 through 6, what was, if any, your favorite problem set problem, be it in Scratch or C or Python? So answer those 2 questions. And in a moment, I'll flip over to my screen here where you'll see, and anyone who's used Google Forms knows, the spreadsheet that's collecting now this data. Microsoft Office 365 can do the same if you use one of those forms. And what you see here now is a spreadsheet in Google Sheets enumerating all of the audience's questions. Language is in column B, problem is in column C, and each row represents one student who has responded. A few of you were super eager for class today at 8:33 a.m. Eastern Time, 10:32, 11:10. OK, so now we're getting into the actual class time here. And if I scroll down, we'll probably see a few dozen, couple hundred answers by now. And yeah, so we're getting a whole lot of answers here. And I'm seeing some patterns emerge, but it's not necessarily obvious to the human eyes what those patterns are. Now, of course, you can use Google spreadsheets. You can like highlight the data, and you can create charts magically out of it. But you can only do what Google lets you do with the data. And same thing for Microsoft Excel or Apple Numbers. But wouldn't it be nice to just be able to manipulate the raw data, relatively simple though it is, to just answer questions about the data? Maybe long-term create your own charts, customize it just the way you want, rather than beholden to like software that's off the shelf like this. Well, how could we go about doing this? Well, let me propose that we treat this data set now as what we're going to call, for now, a flat file database. We'll see today that there's fancier databases, but the simplest database in the world is really just like a .csv file. And we saw that a couple of weeks ago in C. We wrote a bit of C code that used fprintf to write data to a file using commas as the separator. We didn't really do much more with CSVs at the time, though, because it's really annoying, painful, time-consuming, not fun to use C for something like that because of malloc and memory and all that stuff. But with Python, it's going to be much easier. And so anytime you have access to some data set where you can just like download it to your own Mac or PC or your cloud environment, it's sort of a candidate for now writing code to do something with the data. Maybe analyze it right away. If it's been human inputted manually, maybe you have to clean it up by doing a lot of find and replace, but not with your keyboard, but rather with code. And so let me go ahead and do this. Let me go back to my Google Sheet here that has all of the data that's come in now. And let me go ahead and download this via the file menu here. And let's see, download. And you can see a whole bunch of options. Most formats might be familiar, but today we'll focus just on this one, comma, separated values, or CSV. That's going to go ahead and download it on my Mac here into my own downloads folder. And now I'm going to go ahead and do this. Let me go ahead and pull up VS Code in the cloud here. And if you've never done this before, there's a couple of ways to do it. But the simplest way to upload a file to your code space, so to speak, is just to sort of drag and drop. That's going to magically upload it to the server there. And we'll see that, one, it has a very long file name, which I'm actually going to clean this up because that's going to be very tedious to type in my code. So I could either right click, of course, up here, but I'm going to use my Linux command. So let's move this file called CS50 2022 something or other, and let's just name it more simply favorites.csv. So all lowercase, no spaces, sort of good basics. And let me go ahead now and open up this file with code favorites.csv. I'll close my file explorer, and we'll see exactly the same data as before, but not quite as pretty as Google Sheets makes it be. Rather, we see here that I still have 3 columns, timestamp, language, problem, and then all of the values down below, including the timestamps and the answers therefore, but it doesn't have proper columns. It just has commas separating them. Now, we could very easily write Python code, just like we wrote C code, to manipulate files like this, either to write or read. But instead, let's do something that's a little more pleasant, which is indeed in the form of Python. So Python actually comes with native support for CSVs. It has indeed a package called CSV that just lets you read and write and do a whole bunch of useful stuff when it comes to CSV files. So let's go ahead and do something with this file. Let me go back here to VS Code. I'm going to close favorites.csv for now, but just remember in your mind that timestamp was the first column, language was the second column, and problem was the third. And notice because we're using commas, they don't, again, line up perfectly, but that's not a problem. There are 2 commas in every line, presumably. And I'm going to go ahead and now create a file called, how about favorites.py, so that I can start writing some code to manipulate this data. And let's do something simple. Let's just write a simple program in Python that opens this file, reads it, and prints something out, just as like a safety check that I know what I'm doing, even though it's not going to be useful. So in Python, if you want CSV support, you import CSV. And that gives you access to all the magical capabilities thereof. Let me now go ahead and use this technique to open a file in Python, which is similar in C, but with Python, I'm going to do this. The keyword with. I'm going to open a file called favorites.csv, which was the shorter name I gave it. This is optional, but just for explicitness, I'm going to open it in read mode explicitly, just like fopen took a second argument as well. And I'm going to name this file, once opened, quite simply file, though I could call it anything I want. And now it's just an open file. So far as Python knows at this moment, it's just text, or better yet, it's just zeros and ones. If you want this Python package called CSV to actually do something useful with it, you have to load this file now into the library. And the simplest way to do this is to give myself like a variable called reader, because I want to read this file, though this too I could call anything else. I'm going to then set that equal to the return value of a function called csv.reader. And I pass to that, per the documentation, the open file. So step 1, I open the file, and this just gives me access to the bytes therein. Step 2 now, with csv.reader, tells the Python package called CSV to do something useful with it and start analyzing the commas and allow me to parse it further. So let's go ahead and do this. Let me go ahead now, and within this loop, let's say this. Within this opened file, let's do this. For every row, if you will, or line in the file, aka reader, let's go ahead and print out just, how about row bracket 1. Now, what's going on here? Well, it turns out if you read the documentation for the CSV reader function, what it hands you back is essentially this special object, so to speak, that allows you to treat it as though it's just a really big list of lines from the file, aka reader. So by saying for row in reader, this is a way more succinct way of saying, give me the first line in the file, plus plus. Give me the second line in the file, plus plus, and so forth. That we would have done much more mechanically in C. This is just much more Pythonic and English friendly, if you will. So in every iteration of this loop, row is going to contain all of the data from the current row. But better yet, what the reader function does for me is it hands me each row not just as a big string or str of text in Python. It gives me what, apparently, based on the syntax on line 6? Any instinct? Yeah. It's giving me back indeed a list. And I presume the visual clue for you was the fact that we're using square brackets here. And indeed, row bracket 1 is going to be not the first, but the second element in that list. And so just take a guess. When I run this code in a moment, what's going to get printed? The timestamp, the language, or the problem? The language, because it's the second column that is in the file delimited by those commas. So let me go ahead and do this. Let me clear my terminal down here. Let me run python of favorites.py and enter. And there's everything. It was super fast, but there's a really long list here. And in fact, if I increase the size of my terminal and start scrolling up, you'll just see all of the raw data. Now, this isn't that useful yet. I could have just glanced at the CSV, but clearly now I have the ability to open the file, parse it, so to speak, that is, break it up into its constituent parts, and do something with specific parts therein. All right, so if I want to do this a little more pleasantly, though, let me at least make this semantically a little cleaner. And you know what? Just for clarity, let me just give myself a variable. It's not strictly necessary, but I know that this is the favorite, for instance, language. So let's just call it favorite, set it equal to row bracket 1. And now just to be more explicit in my code, even though, again, we don't need the variable per se, this code's, of course, going to do the same thing. It's just using an additional variable called favorite. If I go down here, scroll up, run the program again, I get back the exact same data. But this is a stepping stone to something that's even more powerful about Python support for CSV files, is that you don't have to just treat the return value as a list with 0 and 1 and 2. So just thinking intuitively here, why is this maybe not the best design to hand you, the programmer, back the data in a list that's numerically indexed with 0, 1, 2? It clearly works, but critique this. What could go wrong? What's a little poorly designed? Yeah.
You have to always remember like what the things are, like what the order is.
Yeah.
Stamp language, and then I forgot the last.
Exactly. So it's up to you to repeat. It's up to you to remember like what column the data is actually in. And God forbid you're collaborating with someone else on the spreadsheet. If you've used Google Spreadsheets, you can move columns around, maybe just because you want to visually reorganize things. And if you do this, and then someone else downloads that same data, all of their code is going to break. So that's just really bad design. It's fragile just because you're sort of on the honor system that 1 means the data that you want. So wouldn't it be nice if we could be a little more explicit? Well, recall that the very first line in this file is actually this. And I paused the output this time so that we can see more optionally. I just reran favorites.py. And notice one of these things is not like the other. Every output was either Scratch or C or Python, except for this first one. Why am I seeing the word language here? Where did language come from? You didn't have the ability to manually input. Oh, no? Where did it come from? Yeah. Yeah, the header, the very first row in the file, which by human convention generally just defines what the columns represent so that there's some human useful information there. Now, that's not really intended to be part of my output at the moment. So there is a way to skip this. If you want to skip the first row, you can actually do something like this. You can say next row, and that will just ignore that row so that I'm starting really with every row thereafter. But there's a better way to handle this than that. That will get rid of the row in the output. But let me go ahead and use a different feature of the CSV package that's just going to make this a little cleaner altogether. So let me clear my terminal window here. Let me undo this next thing that I just added. And instead of using a reader, let me go ahead and use a dictionary reader, abbreviated dict reader, that's going to now return me the equivalent of all of the rows, one at a time. So I can still call it reader just as before. But as the name implies, what this reader is going to return is not a list after list after list, but a dictionary, a dictionary, a dictionary. And remember, a dictionary is just a collection of key value pairs. So what does that mean? What are the keys? What are the values? Well, now that I'm using a dictionary reader, I can actually do this. Instead of sort of on the honor system remembering that I want column 1, I can treat row now, not as a list, but as a dictionary. And that means I can go in here and say, quote unquote, language. And we saw that back in week 6. Python allows you to index into dictionaries using square bracket notation in strings or strs on the inside, just like lists allow for numbers. But this now, I think, is going to be a little more robust. If I run this again, python of favorites.py, all of that worked out fine. And let me pause the output too by using this program called more. Now I don't even see the header. So now whoever works with Python wrote the code for this package to just analyze that first line of code, use the header, as you just called it, as the keys. And then every time you iterate through this loop, it updates the values, but the keys stay the same. Any questions then on this technique? Suffice it to say, this would be painful in C. Yes? Exactly. So the keys are always going to be, quote unquote, timestamp, language, and problem. But on each iteration of this loop here, the row is going to contain a different row of values, different row of values, different row of values. So you're going to get back one dictionary for every student who submitted the Google form, if you will, while iterating through it there. All right, so once we have this ability here, why don't we go ahead and transition to, how about not just using that dictionary reader, which makes the code a little more robust, because now if you move the columns around, no big deal. It doesn't matter if the numeric indices change. You can still use those keywords instead. But let's actually analyze the data now. I'm just spitting it out, which is not solving any problems for anyone. So let's go ahead and count the popularity of Scratch, C, and Python and see what everyone's been thinking here. All right, so how might I do this? Well, let me go ahead and do this up here. Before I start iterating, let me give myself, let's say, 3 variables. And to keep things simple, I'll say one variable called Scratch, set it equal to 0 for 0 students so far. C is going to equal 0, and Python is going to equal 0. There's a slightly prettier way of doing this, just because this is like 3 lines of code to do something very simple. You could alternatively, in Python, but not C, do Scratch, comma, C, comma, Python equals 0, comma, 0. So kind of slightly more elegant, just to fit it all into one line. But now let's just do something more interesting. On line 7, I'm still going to figure out what the current favorite language is. And now I'm just going to do some conditional checks. How about if that favorite equals, quote unquote, Scratch? Let's go ahead and increment Scratch by 1. We can't do plus plus in Python, but we can do plus equals 1. How about elif favorite equals C? Then let's do C plus equals 1. We could do else. This is actually a good design question. Should I do else? Should I do elif? Any instincts here? Yeah. Yeah, really good instincts. Just in case someone goes and adds another language to the form next week, because we're obviously going to introduce another language today, you don't want your code to now artificially inflate the scores for Python just because you're conflating multiple languages together. So the more defensive, sort of better way to write this code, I agree, would be elif favorite equals Python. Then let's go ahead and increment Python plus equals 1. And if there's a new language next week, we're obviously going to have to update the code, but at least we're not miscounting. We're just missing the new language. So I think that's slightly more robust. All right, now at the very bottom of this program and outside of the loop, when I'm all done counting, let me go ahead and print out using some f strings. How about the total number of people whose favorite is Scratch? So this is just week 6 f string syntax. Let me go ahead and print out another f string for C. And I'm, of course, putting the variables in curly braces, all lowercase, but the English words I'm doing capitalization for. Let's do a final one with f, Python, colon, and then in curly braces, Python, close quote. And I think I'm done. So let me just hide my terminal for a second. Here's the total program. Same stuff as before. Open favorites.csv. Open it further with the dictionary reader to do that processing for us. Initialize 3 variables to 0 just so we have something to count with. And then iterate over the file row by row. And this is just some sort of week 1 style conditional logic, albeit in Python, counting things. All right, so how can we now execute this? Let me go back to my terminal, Python of favorites.py. And here we go. As of today, everyone who's reporting in live via the Google form, their favorite languages are... Interesting. That's pretty interesting, too, after just 1 week of Python, no less. But Scratch is a healthy contender there, a lot of C, so a pretty good mix here. So is this going to be the best way to write this program long term? Well, as you noted, if there's a new language next week, this week, we're going to have to constantly update this. And here's where you should let your mind wander to like the future. Like if we have a 4th language, 5th language, 6th, 7th, 8th, which aspect here might kind of have some code smell to it. Like this probably isn't the best design to set us up for the future. What might be better than this? Yeah? Yeah, we have to keep adding a language to line 5. And OK, not a big deal. We could add like SQL today and maybe JavaScript next week. But anytime a line of code, a line of logic is just going to kind of grow out of control, and we've had this chat a couple of times with different syntax, there's probably a better way than that. So let's do that. Instead of using these individual variables, we could maybe use a list. But a list would be a little confusing because, like, what does bracket 0 mean? What does bracket 1, bracket 2? But a dictionary, recall, is like this Swiss Army knife of data structures whereby you can associate anything with anything else, keys with values. So I dare say a cleaner way to solve this problem that sets us up for less work or confusion later would be to create like a new variable called counts, if that's what we're doing, counting things up, and just set it equal to an empty dictionary. And you can literally say dict with the open parenthesis, close parenthesis, and nothing. Or the more Pythonic, just use open and close curly braces with nothing inside. That gives me an empty dictionary, just like square brackets gives me a list. Now, my logic down here has to change a little bit. But what's nice is I don't need one conditional for every language. Because again, if we have a fourth, a fifth, a sixth, that chunk of code is also going to grow a bit out of control too. So I can get rid of this here. And what I think I'm going to do is say this. Whatever the current favorite is from the current row in the file, why don't we go into our counts variable at that key. And again, favorite is a variable. It's not quote unquote favorite. It's going to be Scratch or C or Python. And then why don't we go ahead and just increment whatever the value of that count is at that key. Now, this is technically buggy. We're really close, but there is a bug. Does anyone want to conjecture what the bug is? Yeah.
Well, this is more a question, but like, will that automatically add a new key value pair for each favorite, for each like language?
A good question that answers my question nonetheless. So no, like the magic you described will not happen. And to repeat the hypothesis, will this automatically create a key for every language that we try plugging into those square brackets? Short answer, no. Odds are this is going to create a key error, one of those traceback error messages that you've probably seen by now, either in class or in problem sets, whereby if Scratch hasn't appeared in the dictionary before, or C or Python, then the dictionary has no clue what you're talking about. So I think we actually still need some conditional logic, but not that's going to grow longer and longer with each language. What I think we probably want to do is this. If the current favorite is in the counts dictionary, and this is the Pythonic way of just saying, is this key in this dictionary, then go ahead and safely do counts favorite plus equals 1. Else, to your conjecture now, else what do I want to do? Counts favorite equals, 1. So initialize a brand new key to a brand new value of 1, because I'm obviously just seeing this language. Otherwise, increment again and again. And now down here, I just need to tweak my syntax a little bit. I don't need to print out all of these things one at a time manually. I can actually get away, I think, with another loop at the very bottom here. So how about I do this? For each favorite in those counts, and this is, again, the Pythonic way to iterate over all of the keys in a dictionary, go ahead and print out, using an F string, whatever the current favorite is, Scratch or C or Python, and then a colon, and then figure out what its count is. And you can do that by going into the counts dictionary, looking at the favorite key, and get back its value. So I close my curly braces, I close my quotes, and even though this looks ugly at the moment, now this is much more dynamic, because if we go and add SQL to the CSV file tomorrow, or we add JavaScript next week, this will just work. It will keep working now automatically. All I change is the Google form, not my actual code. All right, let's try Python of favorites.py. Cross my fingers as always, and there now is the data as of now. Questions on this code here? Yeah? Really good question. What if you wanted to print it in a particular order? Well, I could give you a couple of solutions. Like if you want to print it out in It's already coincidentally in alphabetical order, so you got that for free, although that's just by chance here. But there is a way to do this. And let me propose that we go down here to my loop, and I explicitly use a function you might not have seen in Python yet, but it's literally called sorted, which is going to take either a list or, in this case, a dictionary, and by default, sort it by key alphabetically. Now, if my intuition's correct, this is not going to change the output because it's already alphabetical. But if you read the documentation for the sorted function, it takes multiple parameters potentially, some of which are named parameters. And so you can actually do this. If you want to sort the counts, but you want to reverse the order for whatever reason here so that it's reverse alphabetical order, now let me go ahead and rerun this. And I'll keep the previous output on the screen. Enter. And now it's backwards alphabetically, if you will. Other questions on this here? No? How about then we transition to sorting by value. And this is going to escalate a little quickly, briefly, but then we'll tone it down again. Notice that right now this is indeed sorting by key. What if, especially if I have lots of data, it'd be nice to make like a top 10 list, or in this case, a top 3 list, and actually see in order of the counts, the values, what these popular ones are. So it's not C, Python, Scratch. It should ideally be Python, then C, then Scratch because of the values and the magnitude thereof. So how can I do this? Well, it turns out there's another parameter that you can pass to the sorted function that is typically implemented as a function itself. And so I'm going to go ahead and do this. I'm going to temporarily define a function called getValue, just to make my life easier. And this getValue function is going to take, I'll say, a language parameter. And then all I'm going to do is return whatever the count is of that language. So out of context, this is just a super simple function that you handed a language like Scratch or C or Python. It's just going to tell you what the count is thereof in that dictionary called counts. But what I can do now down here in my newly introduced call to sorted is I can tell it what to use as its key. Instead of using literally the key, Scratch, C, Python, I can sort of override that behavior and say, you know what? To figure out what to sort by, go ahead and call this function called getValue. Notice that I have not put parentheses after getValue because I don't want to call getValue right then and there. I want to pass the getValue function as itself an argument to the sorted function so that the sorted function, written years ago by the people at Python, can call my version of getValue again and again and again when they try to sort this actual data. So now, if I add that and I leave reverse equals true, let's see what happens. Python of favorites.py, enter. And now I get my top 10, or in this case, top 3 list. And if I had more sophisticated data with like more columns altogether that I actually care about, I could even sort this more powerfully as well. But let me clean this up a little bit just so you've seen it, even though we won't use these that often in CS50 until the end of the class will they come up again. Technically, this is a little bit, this isn't necessarily the best design to spend all this time implementing a function and then only use it in one place. In general, we've argued that you don't necessarily need a variable if you're only going to use it in one place. You don't really need a function if you're only going to use it in one place. And here, we kind of have a good candidate for that. And so it turns out in Python, if you don't want to bother creating a function just to use it once, you can create what's called an anonymous function, aka a lambda function, like the lambda symbol, familiar. And a lambda function, the syntax is a little strange looking, but you say this. You literally say lambda. You literally then say the name of the argument that you want this anonymous function with no name to take. Then you have a colon. And then, quite simply, you write what you want the return value of this function to be. You don't even say return literally. These lambda functions are meant to be used super tersely so that you can, in one line, express something like this. And I admit this looks more cryptic, I think, than the previous version. But as you get more comfortable with Python or other languages that support this feature, it allows you to not bother with lines of code like that and just tighten up your code a little bit. So this line here, lambda, language, colon, counts language, is the one-line version of this. And you don't even need to bother picking a name for it. Lambda tells Python, I didn't waste any time thinking of a name for this function. So questions then on this technique of using Python to analyze data like this. Any questions? We're almost done with Python. Questions? No? OK. So why don't we make things a little more interesting, because we had a much juicier data set with the problems that we've assigned over the past several weeks. Why don't we go ahead and quite simply, I think we wrote pretty darn good code here. So I think we can pretty much just change a bit of it to say, let's see, if I don't want language, I want problem. And if I want to sort by not language but problem, I think that's it. I think if I didn't overlook something here, just by changing what column I'm reading the data from, and then just to be consistent, renaming my variables just so I know what I'm looking at, what will this program now do after those minor changes? What will I see when I run this? What would be the first thing I see when I run this? Tough crowd today. Yes? Yeah, the problem, the top problem. So the most popular problem, which I'm a little worried it might be hello or just Scratch, but let's go ahead and see. So let me go ahead and open my terminal window. I'll even maximize my terminal window so we can see a lot. Let me go ahead and run Python of favorites.py. I'm going to go ahead now and cross my fingers that I didn't mess up and hit enter. And OK, great. We peaked early. So Scratch was the most popular program according to the data at the time I downloaded it. I'm sure other votes have come in since. Filter in week 4 was tied then with Tiedemann as well. Mario is a close third there, and so forth. So this is helpful for us on staff. That's not so much love down here at the bottom of the list. So it was a bunch of code to write, but now that we've written it in this very versatile, dynamic way, it's pretty good for just like crunching data and doing some analytics. But it's still a decent number of lines to have had to write manually. And this is where sometimes it isn't necessarily the right tool for the job, but rather the job that a candidate for using some other language altogether, especially when it's not just a one-time program that you run and you want to see the answer. What if you want to take input from the user and answer questions dynamically, like a mobile app would, like a website would, like Microsoft Excel or Apple Numbers or Google Sheets would for you? Well, let's make one final change for now to this version of the program and actually take in some user input. So besides just loading all of the data into memory, let's go ahead and down below here, not just print out the top 10 list, if you will, but prompt the user for their favorite. So I'm going to use Python's input function, and I'm just going to prompt them with favorite, quote unquote, like tell me what your favorite problem, what problem you are interested in. And now let me go ahead and say if that favorite is in the counts variable, so you didn't type in something random that we didn't actually assign as a problem, then let me go ahead and print with a format string whatever that favorite is of yours and show you the actual popularity thereof by indexing into counts using that favorite as the key and printing this. So now it's a dynamic program. It doesn't dump all of the data and all of the summations. Rather, it's going to allow me to see what my choice of favorite is. And I'm going to go ahead and say, let's see, I'm a fan of Mario here, so enter. And indeed, we see the same value we saw a moment ago, but just for Mario. But the point now is that, 1, all of this is possible. 2, it's way easier and more pleasant than this would have been in C. This is still only 15 lines of code. And in C, again, there's the memory management. There's the iterating over the strings, trying to find the commas. There's just a lot more work. But honestly, even when you just want to answer a question like this in Excel, in Apple Numbers, Google Sheets, generally you can just highlight things. You can click a button and boom, you get your answer for summation or max or min or any of those sort of basics. Wouldn't it be nice if we weren't taking a step backwards as programmers and being sort of more powerful, and yet we now have to do more of the work? So maybe sometimes Python's not, or any language is not, the best tool for the job. And that's going to now allow us to introduce more generally something called a relational database, graduating from mere flat file databases like text files or binary files in which all of your data is stored to something more proper. But first, questions. Really good question. To reiterate, if I were to, is this case sensitive? So if I were to type in Mario in all lowercase and hit enter, I actually get no such response. Now, that might be acceptable because the problem technically, what is a capital M? But that's a little ridiculous to be that pedantic about the input. So how could we solve this? Any tips for how we could make this a little more robust? Yeah? OK, yeah. Yeah, so we could use a few different functions, one of which is called title, which will change it to title case, where capitalize is, like in most English sentences, the first letter of that sentence. We could use capitalize. We could use upper. We could use lower. But indeed, we could just decide how we want to standardize the capitalization, either uppercase, lowercase, or some combination thereof, and just make sure that you change the counts themselves, make sure that you do the same to favorite, and make sure that maybe you keep a backup of the data if you want to show the original version that came from the CSV without presuming to just capitalize everything for the user. But indeed, that would be the most common scenario. You just make things case insensitive when doing those matches. Other questions now on Python before we leave it behind for the coming week? All right, well then let's introduce these relational databases. So relational database is what is a super popular way of storing lots of data. Like this is what the Twitters of the world, the Googles of the world, the Metas of the world use to store some of their data at scale. There are alternatives to relational databases. Indeed, today we'll talk about a language called SQL. There's also a movement, if you will, or an alternative generally called NoSQL, which is just the opposite. You don't use SQL. There are things called object-oriented databases and the like. But if you've ever heard of MySQL or PostgreSQL or Microsoft SQL Server or Oracle or MariaDB or a bunch of other products, both free and commercial, this is what they're talking about. Databases that are designed to store lots of data. And what's nice about relational databases is that they're really similar to the spreadsheets with which you were presumably familiar long before today's class. So a relational database is going to store, as you'll see, all of the data in rows and columns. Now, the terminology will thereafter be a little different. Instead of having sheets, you're going to have tables. But those tables are still going to have rows and columns. And you're going to have even more control over the performance of your data when you start to access it using this structured query language, or SQL. This is a language you can use for web apps, mobile apps. A lot of analysts would sit down at their Mac or PC and actually ask questions of data to get back the answer. And wonderfully, even though there will be some new syntax today, SQL really just does 4 basic things. CRUD is the sort of crude acronym here. CRUD is a way of remembering that a relational database supports ultimately creating data, reading data, updating data, and deleting data. So even if you're feeling like, wow, this is a lot of new syntax, which it isn't relative to our past languages, the only things you're doing really are creating data, reading data, updating, and deleting the same. Now, a little confusingly, in SQL, the corresponding functions or commands that exist that map to CRUD are actually this. So it's still create, but there's another one called insert. It's not read, which is more of the computer scientist way of saying it, but select, which is a little more explicit, like select data you care about. Update is still update. Delete is still delete. But there's another command called drop, which lets you drop, that is, delete entire tables as well. So you can create tables using syntax that's generally going to look like this. You'll say create table. You'll give the name of the table, which you can call most anything you want, but generally all lowercase, no spaces is best. Then in parentheses, you can specify a comma-separated list of the columns that you might want in this table. So this is the code equivalent in the SQL language of like manually opening Google Sheets or Excel or Numbers and like clicking in the top left cell and like typing timestamp. And then in the next, typing language. And then in the third, typing problem. This is the way to sort of define what your headers are, if you will, in a spreadsheet, but now it's called a table. Now, we won't use this command manually first. Let's do something a little simpler. We're going to start off by just importing this data ourselves. And I'm going to go ahead and do this. Let me go back to VS Code here. I'm going to leave behind favorites.py for now, because now we're going to transition to this other language called SQL. And to do this, I'm going to create a new database file. And I'm going to do so using a command called SQLite3, which is just the third version thereof. And I'm going to give the database a name of favorites.db. There's different conventions, but this is one of the most common. When I hit enter, this is going to create for me a new empty database, just like opening an untitled spreadsheet in Excel, Google Sheets, or Apple Numbers. I'm being prompted, do I want to create favorites.db? I'll hit Y for yes. OK. we're up and running. Now you're going to notice a different prompt. I'm not in my Linux prompt per se, which is always the $sign. I'm now inside of the program called SQLite. And we're going to use SQLite 3, as just an interactive way for now of playing with SQL code. At the end of today, we'll show you how you can use SQL in Python code so that you still write Python code to do whatever you want, but you can talk to databases using Python. And this is exactly how web apps, mobile apps work. For instance, on iOS, on an iPhone, an iPad, or the like, if you want to store data, it's very often stored in a SQL database, as we're about to do. But you might use a language called Swift or Objective-C. And the same exists in the world of Android using Java or Kotlin or something else to query the database. So we're going to see SQL in isolation for now, like an analyst might just use it at their Mac or PC, but we're going to tie it together by day's end. So at this terminal, SQLite, let me go ahead and execute this command first. I'm going to first put SQLite into CSV mode because I'm going to cut some corners initially. And I'm just going to automatically import all of the data that was submitted via that Google form, which I exported as a CSV and uploaded to my code space. And I'm just going to automatically say, turn this CSV file into a SQL database for me, just so I don't have to figure out what those create table commands are. So to do this, I'm going to say mode CSV, so that SQLite knows that this is the command, knows that this is a CSV file. It's literally dot mode, so the dot comes before the keyword there. And now I'm going to say dot import, and then the name of the file I want to import, which is favorites.csv. And now the name of the table that I want to create with that data. And just for consistency, I'm going to call it favorites. I could change these things to be anything I want, but I'm going to do that. And voila, nothing seems to have happened. But just like in C and in Python and Linux, when nothing seems to happen, that's usually a good thing. It means I didn't mess up. So if I want to see what just happened, there's this other command. And these commands that start with dots, these are SQLite specific, which is indeed a lightweight version of SQL. They're not SQL per se. So if you're using Oracle or something else like that, you're not going to use these exact commands. You'll see the ones we use in just a moment. And here's the first. When I type .schema, the schema of a database is the design of the database. What are the tables? What are the columns? And all of that. So when I type .schema, this actually, in this case, shows me the create table command that was automatically run for me by just doing this import line. Once I get more comfortable with SQL, I could literally type this out myself or use some program to generate that as well. But what it's creating for me is this: create table. If it doesn't exist, even though it's more terse than that, I want to create a table called favorites. And then the columns for that table are going to be timestamp, which is going to be text, comma, language, which is also going to be text, comma, problem, which is also going to be text. That was just inferred very trivially by the .import command to just figure out that, yes, just give me a 3-column database table based on the Google form. Okay, questions on this? These are commands you run once to get up and running. You don't run these commands frequently. But we have them on the slide just for reference. All right, so now let's do something a little more interesting. I'm going to clear my SQLite terminal here, but I'm still in SQLite. I'm going to now use some of my first SQL commands, which recall were among them select. So CRUD, C-R-U-D, the R was select. This is maybe the most common, the most useful, the most powerful thing to use with a SQL database, selecting data to answer questions akin to the ones we were trying to answer with Python. This is the general syntax. Anytime you want to select data from a SQL database, you literally say select. You then specify the column or columns that you want to select data from. You literally write the word from, and then you specify the name of the table you want to get that data from, semicolon, in this case. Everything that's in capitals here is a SQL keyword. Strictly speaking, you don't have to capitalize things, but we would encourage you to do so stylistically. And especially as you're learning and even as you're writing it, it just helps to distinguish SQL from like words you chose, like the names of the columns and the data therein. So do adopt early on this convention. So let me go back now to my code space here. I'm running my terminal window with SQLite 3 inside of it. Suppose that I just want to get all of the data from the favorites table, which was automatically imported. Let's do this. Select. I want everything. Well, I can do timestamp, comma, language, comma, problem. But you know what? Here's a convenience already. If you want everything, there's what's called a wildcard character in SQL, which is just a star, an asterisk, which means give me every column without my knowing even what they're called. Let me go ahead now and say from favorites, semicolon. And this is the SQL way of opening the database, iterating over every row therein, printing out every row therein, done. So those 3 steps, which was like 9 lines of Python code, give or take earlier, is now 1 line of SQL. I hit enter. There is all of the data. So I see now all of the data just outputted as a CSV here. But it's not the CSV file. It's now actually the table. And in fact, just for good measure, let me do this, because you'll see the behavior a little differently the next time we open the file. I've just exited out of SQLite 3. I'm going to rerun it. But I'm not going to re-import the data or do anything like that, because my file now exists. In fact, let me take one step back. If I type ls at my Linux prompt, there's my favorites.py from before. There's my favorites.csv from before. And here's a third file that I did create a moment ago when I first ran SQLite 3. So the data is persistent. It's not using RAM or memory. Anything I do now is saved there. So let's go ahead and rerun SQLite 3 with the same file. But I don't have to re-import everything because the file already exists. Let me now do that same thing again. Select star from favorites to get all of the data. And what you'll see now is the same data, but it's a little prettier now. Because I reran it, I effectively disabled CSV mode this time. And what I'm now seeing is the entire contents of this database table called favorites. Now, there's nothing new here, but you're just seeing now like an ASCII or Unicode version of all of the same data from that database. Well, suppose I want to get a subset of the data. Well, let me clear my screen. And just like in Linux, I can hit Control-L just to clean things up aesthetically. Suppose I want to get just the languages. So I could do select language from favorites. And this will now select not all 3 columns, aka star. This will only select the language column and all of the data therein. If I hit enter, voila, now I just see those there. No timestamps, no problems. It's just a slice of the table, if you will. All right, not that interesting still, because it's just a big column of data. But now things get more interesting. It turns out in SQL that there are functions that come with this language, just like C, just like Python. In SQL, some of the more useful ones, some of the simpler ones are these here: average, count, distinct, lower, max, min, upper, which pretty much do what they say. And count is a particularly useful one. Let's start with that. You know, it's a reasonable question to be asked. How many people submitted the Google form by the time I actually downloaded the CSV? Well, why don't we go ahead and do this? Let me go back to VS Code here in my terminal window. Let me select not star, but the count of star. So give me the count of the rows that are being returned from the database called the database table called favorites. Now when I hit enter, I'm not going to get all of the data. I'm just going to get simply a number. 430 rows came back. So that's pretty good. I now know how much data is in there. Well, what languages were in there? Well, I could do select language from favorites just as before, but that's not that useful, especially if I'm inheriting the data. Like I'm the analyst who's been handed a data set by my boss, and they want me to like crunch some numbers. OK, I could like load this into Excel. I could sort it. But you can use SQL now to answer pretty basic questions too. If you want to select the distinct languages in the data set because you weren't privy to the Google form, let me go ahead and select only the distinct languages from the favorites table. And now I hit enter, and I get back a much more succinct answer. Just the 3 languages in question. Not really that useful since I created the Google form, but certainly if you're inheriting data from someone else, you've just downloaded a data set, at least now I'm arguably wrapping my mind around what's going on. Now, this is not necessary for such a small data set, but I can combine these things. Select the count of the distinct languages in this data set called favorites, and now I should get back what answer? So hopefully, indeed, an answer called 3. And what you're getting back, notice, aesthetically too, is like a mini temporary table. When I asked for just the distinct languages, what SQL hands me back is this temporary table in memory that has 1 column called language and then 3 rows. Now, this is not saved anywhere. It's just executed ephemerally like this. But that's why it's depicted in this way. What you're getting is subsets of your data, smaller tables containing some of your data. And same thing down here. This is like a crazy long column name. You can rename it if you really want. But that's all we're seeing there. And in fact, if that's a little ugly, we can actually alias these things. N is a common name for a variable, a number in any programming language. So I can actually alias this to be a column called n, hit enter, and now I'm getting a tiny, tiny table whose column is called n that just has the one value there. All right, questions on these, application of these functions here? No? Questions? Yeah. Say a little louder. Oh, as, so literally in English. So name this column, rename this column as this. Technically, it creates an alias for the column. So that's all. Yeah. Exactly. Distinct will operate on whatever you handed in parentheses and get rid of all of the duplicates, giving you back just the uniques. Correct. Other questions here? Yeah.
When n becomes an alias of the table, does that become someone of a variable that you can call back to later on in the program?
Good question. When you define an alias like n, which I just did, does it become like a variable you can reuse? Short answer, no, in this case, but you can reuse it within your same query. Even though these queries are getting a little longer, admittedly, statements that they are, you can actually reuse n in even longer queries, so later in your query. And we'll see a few that are going to start to grow in length. So it's a nice way of nicknaming things just to be a little more terse in your query. So we can transition to some of these more sophisticated queries because it turns out there's some other techniques we can introduce as well. Here are some other keywords in SQL. And again, even though like this is another list of things, there's only 4 things fundamentally we're doing: creating, reading, updating, and deleting data. These are just allowing us to like fine tune how we do it exactly. So where is going to allow us to filter data, as we'll do in just a moment. Like select data where this conditional is true. Like is going to be an alternative to an equal sign. So instead of looking for exactly Scratch or exactly Python or exactly C, you can look for something like ... And it can be a little bit of a fuzzier match, if you will, with other characters as well. Order by is going to deal with sorting. Limit is going to just let me limit the total number of rows that come back to 1 or 10 or finite if I don't want to see all 400 plus rows all at once, because I'm just trying to wrap my mind around it. And group by is best shown by example. So let's play with just a couple of these as well. Let me go back to VS Code here. I'll clear my screen. I'm still in the same SQLite instance. And let's count how many of you liked C without writing Python code as before. So let me go ahead and select the count of the rows from favorites where the language in each row equals C. And the convention in SQLite is to use single quotes anytime you're surrounding a string that's meant to represent a literal piece of text, as opposed to C, which was double quotes, or Python, which was either. So this is selecting the count of rows from favorites table where the language in question is C. Enter, and this gives me 98. Notice, though, if I omit that predicate like we did before, you'll get back the total number of rows that were in the table. So where is what's called a predicate that just allows me to filter things, just like an if condition or the like in a language that we've seen before. You can be a little more specific, like how many people really liked C and the Mario problem specifically. Well, let's do this. Let's go ahead and do select the number of rows from the favorites table where the language is C. And, so it's still literally the word ands and or, just like in Python, but not like in C. And problem equals Mario. So let's see if there's any fans of both C and the Mario problem. And 3 of us really like those 2 things together in this case. All right, what else can we do? Well, more compelling might be to see, kind of like in Python, for each language, what was the popularity thereof? And at the moment, we don't really have a way of doing that except in Python, where we had the loop and we had those variables or the dictionary that did all of that counting for us. You know, totally doable, but tedious, especially if your job is to analyze data. My God, like even writing 15 lines of code to answer simple questions is kind of ridiculous. SQL can do better for us. So let me go ahead and do this. Let me go ahead and select every language and the count thereof from the favorites table, but this time group by language. So this was another one of the keywords that we can use in this abbreviated list of extra features of SQL. And this one's takes a moment to wrap your mind around, but this is going to give me a 2-column temporary table where the first column is a language and the second column is the count thereof from this data set. And group by language just means that only show me Scratch once, only show me C once, only show me Python once. That is, group all of the identical values together, but keep track of how many of them there are. And so now, if I go over to SQLite and I hit Enter, now I have, in SQL version, the exact same output that I had from Python that took me, what, 15 plus lines before. Now we're down to just one, because SQL, structured query language, is all about constructing queries like this to answer questions and get back answers quickly. If we want to clean this up a little bit, you asked earlier about sorting order. Well, we can do that too. There's another key phrase we can use here. We can order by the count of those rows and then run that query here. So now, unfortunately, they're from smallest to biggest, but we can reverse that. It turns out, and my query is starting to wrap here. I'll zoom out for a moment. If you want to order by count, the default is in ascending order, abbreviated ASC. If you want to reverse the sort in SQL, instead of using reverse equals true like we did in Python, you say DESC for descending order. And now we get almost the same output, but flipped in reverse. So it's just a lot faster to answer questions once, of course, you get some muscle memory and some comfort with it. Well, what else can I do? You know, what if I just care about the most popular language? I don't care about the second place or the third place languages or anything else. Well, let me add one more clause here. Limit the answer to 1. And no matter how many rows should come back now, I just get the number 1 language as of the data set we collected with 270 votes for it. Questions on this? Any questions here? No? Well, what if, you know, we're starting to introduce SQL, and it was kind of too late to make it into the Google form. So it turns out there's syntax for this too. You can create data, of course, not just the tables, but the data they're in. And here's like the typical syntax for inserting data into a SQL database. You literally say insert into the name of the table. And then in parentheses, you specify one or more columns for which you have values that you want to insert. This is to say, you don't have to give values for every column in the given row. If you only have answers to some of those questions, you can enumerate them here like this. But the values you insert are going to be these. So you literally say after the close parenthesis, values, and then in a second set of parentheses with the same length comma separated list, you specify what values do you want to insert. So it's a little verbose. And frankly, longer term, you're going to use like Python code to automatically do these kinds of insertions. But let's go ahead and try this. Right now, if I do select distinct language from favorites again, we see this, just these 3 candidates. But we've now taught you a bit of SQL, so let's do insert into favorites, the column called language. And you know what? I'm going to give a problem here. The values for which, and let me zoom back out, are going to be quote unquote SQL and quote unquote 50ville. You'll soon see what that's all about. Semicolon. Nothing seems to happen, but that's usually a good thing. And now if I scroll back up in my queries, in SQLite 3, you can scroll back and forth in time and, to avoid retyping things. Now I should see, indeed, 4 candidate languages here. Now suppose that you were never really a fan of C, and maybe you programmed a little bit in high school or in the real world, and you liked C++. Well, there's a whole lot of answers for C. So select star from favorites where language equals quote unquote C. So here's everyone who submitted the answer for C. Let's presume that no, they didn't really want C. They wanted C++, which is not a language we teach in the class. But I could also now do this. You can use the update command to set a column or columns to different values where some condition is met. So if I do update table name, set column name equal to some value, filtering it perhaps by where some condition is true. So suppose I've changed my mind, or you know what, let's go ahead and do update favorites, set language equal to maybe C++ where language equals C. Now this is destructive, so you generally don't want to do this unless you have a backup of your data too, overriding what people's answers are. This seems to have been successful because no error messages. And if I rerun the previous select, that gives me all of the favorites where language equals C. Now indeed I get none. But if I search for C++, now I get a lot. And if I get rid of that where clause altogether and just look at the contents of my database, now you see that indeed C++ is commingled with all the other data. This is not what you all intended, of course, so I can undo this. Let me go ahead and undo what I just did. Let me set my favorite language to C, where language equals C++, but the predicate is important. This I'm not going to do. What if I accidentally omitted this predicate, the where clause? How would that screw things up, might you think? Yeah, and back. It would set every row's language to indeed C. And this is dangerous. And if you start Googling around for like SQL mistakes or the like, people in the real world have accidentally run commands like this. And without naming names, a former member of our teaching staff at one point accidentally ran a command like this and changed every student's name in our database to Bobby, I think it was. The same name for every row because they simply forgot a predicate. So here too, like there's dangers in code. And you should adopt the habit quite quickly of always, one, backing up your data, like with CP, for instance, in Linux, or any other technique, or just making sure before you hit enter that, yes, this is indeed the query I want to execute. And generally speaking, in the real world, there should be process controls in place, like the intern should not have access to the database, the production database, the live database, and the like. But you have a lot of power now with these queries, so just be all the more careful, because very easily can you do bad things. So let me undo this. Where language equals, quote unquote, C++, and I'll zoom back out, enter, and now I think we're back in business. C is among the answers. Yeah? Is essentially doing what at the end? It's essentially find and replace. Yes, in like layperson's terms, this is find and replace implemented with SQL. And in fact, the authors of Microsoft Word or Google Docs might very well be using language like this SQL when you go to the nice graphical user-friendly find and replace box. This may very well be what they're doing underneath the hood. Or, of course, they could be using some other language altogether. There's one last syntax that's worth knowing, delete, which for better or for worse is even more destructive, whereby it allows you to delete rows from tables. It's distinct from drop, which lets you delete tables themselves. This focuses on rows. So suppose that you really didn't like, let's say, Tiedemann was a little challenging if you tackle that more comfortable problem. So if you really don't want to even think about Tiedemann anymore, so why don't we do delete from favorites where problem equals, and I won't execute it for real, Tiedemann. This would have the effect of deleting every row, including the language therein and the timestamp, where the student answered Tiedemann. Worse than this would be this. Why might this be bad? Okay, chuckling, because like there's no predicate, there's no filter, which means literally this would delete all of the data. So again, with great power here comes great responsibility. Now, this has just been a data set of, 430 rows by us dynamically created. There's, of course, some really juicy data sets in the real world. And one website you might have heard or an app you might have used is IMDb, the Internet Movie Database, which wonderfully makes some of their data available for download as CSV files or technically TSV files, tab-separated values. But what we did in advance of class was download some of that data for both TV shows in the real world and movies in the real world. And what's wonderful about this data set is it's not just dozens or hundreds or even thousands of lines. There are millions of rows of juicy data, TV shows and movies with which most folks are probably familiar, at least with a subset. And we'll see in just a little bit that this data comes in the form of now 6 different tables that we've given you. And the tables in question for today are going to be the people in the TV business, the stars therein, the shows that people are producing and the like. This is a picture we'll revisit to enable you to wrap your minds around what the actual data is. This feels like a good opportunity, though, for a snack. In fact, in just a moment, we have a whole lot of Rice Krispie treats out in the lobby. But if folks could perhaps acknowledge this mini wedding cake here. CS50's own Carter Zenke is getting married this week. So congratulations to Carter as well. Congrats. All right, there's only... OK, there's only one piece of cake in that box, but a lot of Rice Krispie treats in the transept. Let's take 10 minutes, and we'll be back with Internet Movie Database in 10. All right, we are back. So if you've never been, like, you can actually go to imdb.com right now and play around or download the mobile app. And it's just big database of a lot of TV shows and movies and actors and the like. But what indeed is nice is you can download some of that data. And that's what I've done in advance. And what we've done is we wrote some Python code to convert some of the flat file databases that they let you download. And we converted it into a SQL database with 6 tables. So not just one, but 6 that ultimately are these here. And let me just help you wrap your minds around what this picture is, which is an entity relationship diagram, which is just to say each of these boxes on the screen represents a table, and each of the arrows or edges represents some kind of relationship across the tables. Because up until now, the only data we had were those 3 columns in the favorites table. But what gets really useful about SQL databases, just like a Google spreadsheet or an Excel file, is you can have multiple sheets, or in a database, multiple tables. And so what we're about to see is that in this IMDb database for TV shows, there's going to be a dedicated table for all the people in the TV business. There's going to be a dedicated table for all of the TV shows that are in their database as of right now. There's going to be a dedicated table for writers in that industry, for the ratings of shows, for the genres to which shows belong, comedy and the like. And then lastly, there's going to be this table which somehow associates people with the TV shows that they star in, and vice versa. And so let's consider first what this looks like in code. And we'll see that it's going to overwhelm intentionally at first. But I'm going to do this. I'm going to go back to my terminal window. And during the break, I downloaded from the course's website a file called shows.db, which we made in advance for you. And if I type ls, I'll see all of my favorites files from before, the CSV, the DB, and the Python file. But now there's shows.db. So I'm going to go ahead in my full screen terminal window here. I'm not using actual tabs or code files now. I'm going to run SQLite 3 on the file called shows.db. And I'm just going to see this version information here. Let me clear my screen and run the one command I ran earlier to show us the schema of the favorites database. Now we'll see the schema for the shows database. And there's a lot going on here, but let me scroll back up to the very top, the beginning, and we see this here. So when I run .schema, we see a dump, really, of all of the SQL create table commands that were run in order to create this database for you. And one of those tables is called genres, and another people, ratings, shows, stars, and so forth. And the columns therein, even though it's formatted a little more prettily than the automatically generated create table statement for favorites, whereby we have one column per line of output here. In the, for instance, people table, there's going to be an ID column, like a unique identifier, like a Harvard ID, a Yale ID, or the like, a name column, a birth year, and then some other stuff. If I scroll down to shows, every show in the world is going to have a unique ID as well, a title, of course, the year in which it debuted, and the total number of episodes as of the time we downloaded the data. And then what else is there? Some of these are a little less obvious, like ratings here. So ratings don't have an ID column, but they have a show ID column and a rating, like a 5-point scale or 10-point scale or the like, and then the total number of votes that were collected to contribute to that rating. IMDb allows people to like upvote and downvote shows and movies and the like. And then similarly is genre structured. There's a show ID, and then there's a genre, which is going to be like an English word like comedy or drama or something else. And then what else? Let's go a little further at the bottom here for stars and writers. If we go to the very bottom here, stars and writers are similarly structured too. They have a show ID and a person ID. So show and person. And then this writers table has a show ID and a person ID. And there's a whole lot of other words that we'll come to in just a moment. But what is this code hinting at? Well, if I go back to the picture from earlier here, you'll see that this picture captures the relationships among these various tables. So for instance, if we focus on shows for just a moment, a show, again, has a unique ID, a title, a year in which it debuted, and a total number of episodes. If you want to figure out what genre or genres a show belongs to, because some shows are just comedies, some shows are just dramas, but some shows are arguably comedies and dramas depending on the episode or the like. So you can imagine wanting to associate 2 or 3 or even more genres with a show. This line here in this second table allows us to do that. Every row in the genres table, we'll see, has 2 items, a show ID, which relates to the ID of a show. And that's why these lines literally line up with that specific column name. And a genre, which is going to be like quote unquote comedy, quote unquote drama, or something else. Now, with that said, design question, why have we deliberately not just gotten rid of this genres table and made our lives simpler by just adding a genre column to this shows table? And again, a table is just like a sheet with rows and columns. At the moment, shows only have 4 columns: ID, title, year, episodes. Why not just add a 5th column called genre and put the show's genre there? Any intuition here? Why not just keep things simple? Like, yeah, in back. Exactly. If you add a 5th column here and call it genre, then you have to pick a genre specifically. You have to put in that cell, presumably, comedy, or drama, or musical, or something else. Now, you could write multiple words in the cell, but generally speaking, that would be sloppy, bad design. Like every cell, just like in a spreadsheet, should really have one value. It might have multiple words, but it shouldn't be like a weirdly comma-separated list of multiple things. It should just be in a different cell in that case. So if you instead were to design this with just a single column called genre, you're imposing what a computer scientist would call a one-to-one relationship. Every show has one genre. And that's not necessarily a good thing. Or strictly speaking, it would be a many-to-one, because the same genre could belong to multiple shows. But each show could only have one genre in that case. What a relational database allows you to do, and relational is indeed the operative word, it allows you to factor out some of your information and then have maybe one show here in one row. But then in this genres table, you could have one row for that one show genre, or you could have 2 rows in the genres table for comedy and for drama. Or if it has a 3rd genre, you could just add another row here. So you still have one row for the show itself with all the juiciest details, but a variable number of rows by having this relationship with another table. Meanwhile, ratings work the same way, at least in this case. A show has ID, title, year, and episodes. But if you want to figure out its rating, you have to kind of follow the arrow here, so to speak, and look up the corresponding show ID in this table, find the rating of that show, and the total number of ratings. So that's been factored out too, for better or for worse. Now let's consider people. People have just 3 columns: ID, name, and birth. But there's no mention of the TV show in which people have starred, or the TV shows that a person has written. Well, why is that? Well, if you just had a 4th column here called show, well, you would have to decide what show is that person in. And no one could ever act again in another show because there's no room to store the data. But if someone, of course, a popular actor, can star in multiple shows, well, we could have one ID for that person, one name, one birth year, obviously. Like there's only one Steve Carell as an actor in the world of people. But Steve Carell, in this example, could have his person ID, whatever his Harvard ID equivalent, Yale ID equivalent is, appear in multiple rows in this table so that it can be associated with multiple shows. And this allows you to create what's called a one-to-many relationship, or technically it's bidirectional. It's a many-to-many relationship. Why? Well, one show can certainly have multiple people in it and multiple people writing for it, just in the real world. But conversely, one person could certainly act in multiple shows or write multiple shows. So this is what you get with relational databases. You put your sort of canonical data for people in one place, for shows in another place, and then you use these additional tables to relate one thing to another. So we won't dwell on the pictures. That's just if you sort of can wrap your mind around the data set better that way, that's one way of thinking about it. But recall that the code we just saw for the schema, again, escalated quickly. Like there's a lot of keywords I haven't mentioned yet, but some of these are perhaps familiar. They're capitalized differently here, but integer is on the list here. Null is on the list, albeit technically not null. So let's tease apart some of these keywords and consider what they're actually doing for your database, because now we're exploring features that do not exist in the world of spreadsheets alone. So it turns out in a SQL database, specifically SQLite, which is the version of SQL we use in CS50 and which is commonly used for things like mobile applications nowadays. It's like a lightweight version of SQL. It's when you aren't trying to run Twitter and have billions and billions of rows necessarily. You've got hundreds, thousands, tens of thousands, maybe even a few million, but not crazy numbers, crazy amounts of data. In the world of SQLite specifically, there's these 5 data types. So just like in C, we had int and char and the like, in SQL, we have these. Blob, which is kind of funny, but it just means binary large object. So it's like a binary data type, zeros and ones that aren't necessarily fitting into the other categories. Integer, which of course is an integer as we know it. Numeric, which is kind of a catch-all for numbers that are formatted specially. So like a date would be like year, 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 dash month, month, dash day, day. And this is actually a wonderful thing. Depending on the country you're from, you might think your date system in your country is great or it's horrible. The US system is horrible because we have month, day, and then year, which is impossible to sort. It is the wrong way, objectively, to store data, and yet here we are using this at scale. Other countries have gotten this better. Numeric and SQL itself standardizes that stuff. So it doesn't matter what country you're from, you're storing your data in this particular way, for instance. Times are standardized in other types of numeric data as well. Real is synonymous with float, so something with a decimal point and some number of digits thereafter. And then text is just for strings and the like. With other, even fancier databases like MySQL, PostgreSQL, Oracle, and other products you might have heard of, there's even more data types where you have to make even finer grained decisions. But for SQLite, it's indeed pretty lightweight, and you or we just have to decide the data types for each column in a table. But there's these additional constraints in the world of SQL. You can additionally say that cells in this column may or may not be null. So if you want to protect yourself from yourself so you don't screw up and insert a null, that is a blank value, you can explicitly design a table to have a column that cannot be null. And so in fact, someone came up during the break to ask me about my having manually inserted SQL, quote unquote, SQL into our favorites database. You might recall that I kind of cheated. I just inserted SQL, quote unquote, and 50ville, the name of a new problem, quote unquote. But what did I not insert into the database? A timestamp. And I could have put like the current day and time a few minutes ago, but I didn't. And that's fine if it's acceptable to you and the product you're building. But I could have prevented that. If we had defined the table to have a timestamp column that isn't just text, but it's text that's not null, SQL would have complained and would not have let me complete that insertion. So there's these kinds of built-in defenses that you don't necessarily get with a spreadsheet alone. And unique means exactly that. If you want to make sure that every row in that column is unique, maybe for email addresses, or in the US, social security numbers, or anything that you want to make sure you don't have 2 versions of, you can specify that the column is unique. And there's other such constraints as well. But again, this is just a list of features that you get from a proper relational database. But perhaps the most intellectually interesting one and the most powerful one is what's called here a primary key and a foreign key. And let me go back now to this output. If we look at shows, you'll see that a show, again, has an ID, a title, a year, and a number of episodes. And now the data types might make sense. The ID, it turns out, just like a Harvard ID, a Yale ID is going to be an integer, so a simple number. The title, of course, is going to be text, but not null. Like, it would be weird if a TV show had no name. Like, that can't be. Like, the whole world would break, or your TV guide and whatnot. So that makes sense there to say not null. Year is numeric, so it's a standardized form. Episodes is an integer, like how many episodes have been produced. And then lastly, notice this. The primary key of the shows table is apparently the column called ID, mentioned a few lines earlier. This just means that the database will use the ID column as the unique identifier. So it's similar to the unique keyword, but primary key just means the database is going to treat it as special too and make sure that it is uniquely identifying your data. But what's interesting is this. Notice if I scroll back up to people, people were sort of similarly structured, but with different attributes. Like up here, we had a person has an ID, a name, a birth year, and a primary key of ID. So ID is, again, integer. Name is text, but not null, because it'd be weird to have a human with absolutely no name textually. Birth is going to be numeric, but the primary key of people is ID as well. So those are the unique columns that the database will just treat special. Why? Well, we just looked at shows. We just looked at people. Let's focus now on this one down here, stars. How do you determine who stars in a TV show? Well, we had 2 columns, the show ID and the person ID. This is the incarnation of a many-to-many relationship. One person could be in many shows. One show could certainly have many people in it or writing for it. But notice this. Within this table of two columns, show ID and person ID, there's what's going to be called a foreign key called show ID that references the shows table's ID column. And then another foreign key called person ID, though I could call these things in parentheses anything I want, that references the people table's ID column. Now, you're not going to often have to type commands like this. Again, you set the database up once in the beginning, typically, maybe with some help from a TF, maybe with help of Google or the like. But once your database is designed, it's back to the CRUD, like create, read, update, delete, the selects, the inserts, the deletions, and the like. But what's this implying? These keywords like primary key and foreign key are what are doing in code what this picture was painting a moment ago. These lines here are drawn literally to line up with the corresponding things. People's ID lines up with person ID. Show's ID lines up with show ID. And so you're just seeing graphical version, graphical code that creates these relationships. Now, given that, let's actually see what these things look like. So let me go back to VS Code here. Let me clear my screen. I'm still within SQLite with shows.db. Let me go ahead and do what I do with like any new database. If I ever download something or I'm trying to wrap my mind around a problem, usually it doesn't come with a pretty picture or a 3-hour lecture to explain what the data set is. Rather, you just have the data set and your own knowledge of SQL. So let me play around. So .schema shows me all of the tables. That might be a starting point. OK, this is interesting. I know what people are. Let's go ahead and show me all the people. So select star from people. I'm just trying to wrap my mind around what this data set looks like in a more user-friendly way. OK, that's already a lot of people. As you see the years flying by, there's been a lot of people in the TV business. So this was maybe not the best query to run, but this is indicative of just how large this data set is from IMDb. OK, when in doubt and whenever you lose control over your computer, Control-C is your friend to interrupt. What would have been better? Because I don't think I need to know all of the million people in the world. I could do like, limit me to 10 people. All right, and that's enough now to get a sense of like Fred Astaire. It has an ID of 1, first person ever. Birth year of 1899. Lauren Bacall and all of these other people from yesteryear, you see that they are the first 10 people in the database. So there's an example of some of the data. Now, if I want to wrap my mind around what a show is, I know it technically, I know it from the picture, but let's just look at some raw data. So instead of saying select star from people, let me go ahead and select star from shows, limit 10. And OK, I've only heard of or seen a couple of these, but these are older shows at that. But I see that every show has an ID, a title, a year in which it debuted, and a number of episodes. But perhaps most opaque is going to be this. Select star from stars, where this is the table that associates people with shows. Am I going to see any names or show titles here? Not according to the definition we saw earlier. Oh, I should have done my limit. Let me interrupt that. Let me do that again. Limit 10. No. And this is where now you're definitely in the programmer world, because like this would be the most annoying spreadsheet to use on your Mac or PC ever. If you just had like a sheet with all of these numbers that associates one thing with the other, like my God, how do you figure out who this is or what this is? You have to like manually Control F or Command F looking for the data. But a database doesn't care. Once you know SQL, you can sort of stitch these things back together. So what you're seeing here are foreign keys. Foreign keys. Why? Because show ID corresponds to the same numbers from that other table called shows that has a proper primary key called ID. Person ID is a foreign key in this context because it refers to numbers that belong to, really, the people table and its ID column. So this is just a way of somehow linking them. And so if you think of, I always think of this in my mind's eye as this. If this is like the people table, this is the shows table, and there's this middle table in between, the stars table, there's some way of like stitching those two together by lining up the IDs of one with the other and getting back some more data. So let's actually play with some of this data. How about we start where we emphasized earlier, genres. So let me go ahead and take a quick look at all of the genres in this database. So select star from genres. Star is usually going to be a little overwhelming, but it just gives me a sense of what the data is. But let's actually look at, let's go look at all of them there. OK, that's a lot. These are all official genres from IMDb. Let me, oh, OK, it went OK. It wasn't terribly long. Let me filter that down. So from genres where genre equals comedy, capital C, just based on the data I'm seeing. OK, so what am I seeing now? and in fact, let me limit this arbitrarily to 10, though I could limit it to anything I want. Here are 10 comedies. What are they? Well, who the heck knows? Like, all I know are the 10 show IDs. Now, I could do something like this. As we've seen before with SQL, I could do, all right, well, let's figure out what this show ID is. Select star from shows where the ID of the show I'm looking for equals what? 62614 semicolon. So I could like manually look it up by cross-referencing the other table. OK, so that was the show in question there, the first comedy in the data set. Let me look up the second one. So instead of that, let's do 63881 enter. OK, so that's that show. And let's do one more. And suffice it to say, this is just getting tedious and vulnerable to mistakes quickly. This surely can't be the way to do this. And indeed, SQL is going to let us do this a little more powerfully instead. Let's do this. Instead of getting this table temporarily with all these show IDs and all these genres, let's refine the query. So let's just select the show ID from the genres table where the genre equals quote unquote comedy. Now I have a big list of show IDs, all of which are comedy. How many? Well, I can combine ideas from earlier. I can just count all of those show IDs, or star if I want to just do that too. But I can count all those show IDs, 48,706 comedies in IMDb's database for TV shows. So it feels like a lot. But how can I now use that information and get back the titles of comedies in the database without doing it manually? Well, let's do this. I have a moment ago this query. Select the show ID from genres where the current genre is, quote unquote, comedy. What if I kind of nest these queries, kind of like grade school math in parentheses? What if I combine this whole thing in parentheses? And now let me select what I really want. Let me go ahead and select, how about the title of all shows where the ID of the show is in this list of show IDs. So if you agree that the shows table has an ID column, which is otherwise known as its primary key, the unique ID that identifies it, just like our Harvard IDs, our Yale IDs, and you agree that per a moment ago, this shorter query will give me back just the show IDs of all of the comedies in the database, you can actually combine or nest these queries together. It's going to respect SQLite order of operations with parentheses, just like grade school math. So the thing in parentheses will be executed first. That gives it back a list of IDs, like what, 48,000 IDs. And then this query, the outer query, is going to get the title from all of the shows where the ID of the show is in that big list of 48,000. So if I now execute these together, I think the list is still going to be a little long, but let me execute it together. Now I see this long list of outputs, a little overwhelming. Let's go ahead and maybe limit it to just 10, as before for discussion's sake. And now I see 10 comedies ordered arbitrarily from however they're in the database that happen to indeed have comedy as their genre. If I want to do this a little more cleanly, I could do this. Let's see. Why don't I order by title, ascending order, which is alphabetically, or the default is also ascending, limit 10. Now I see the top 10, weirdly named things with hash symbols, presumably to get their titles up to the beginning, or maybe these are hashtags. Here now we have alphabetically the top first 10 shows that are comedies. Any questions on these kinds of queries? It's kind of a lot, but at the same time, it's just like composing the smaller ideas from before into slightly more useful queries. Yeah? Do foreign keys have to set the relationship? When you create the table, the programmer or the database administrator would create that relationship by using those keywords primary key and foreign key that teaches the database what is related to what per the picture. So you do that once. And now, I being the sort of programmer who's familiar with the database, I am just using these foreign keys in a manner consistent with their design. And this is where it's useful at some point, even if no one hands you a picture, to make sure you understand the database, because that's going to inform literally what you type in SQL to get the data you care about. Well, let's do something a little more precise. How about, very reasonable question, and honestly, this is exactly what imdb.com and the app are for. What if you want to find all of the shows that Steve Carell is in? like kind of a reasonable query, like literally something someone might type into Google or more specifically IMDb. It's not really obvious at first glance how to do that, though, because, right, like from my database, if these are my 6 tables, well, I can pretty easily get Steve Carell from here. But I can really only get his ID number, whatever that is, his name, which I know already, and his birth year. OK, interesting, but has nothing to do with the shows that he's in. I can look at shows over here. But there's no mention of Steve Carell, right? Because there's no person ID here. Where is that relationship implemented? Well, it's implemented down here. So how do we do this? Well, here's the perfect example of a lesson we've been trying to emphasize for weeks of taking these baby steps, like break larger problems down into smaller ones. And let's do something like this. Let's just get everything I know about Steve Carell from the database. Let's select star from people where the name of the person is, quote unquote, Steve Carell. I just want to see what data we've got. And here's what we have. OK, there's only one Steve Carell, born in 1962, and his unique ID is 136797 according to IMDb. This isn't some like global actor identifier per se. All right, well, how do I get now all of the shows that Steve Carell is in? Well, I could do this. Select star from stars, not to confuse the two. One's the symbol, one's the table name, where person ID equals 136797. So I think this will now give me everything from the stars table that relates to Steve Carell. OK, and you'll see person ID is the same because I'm literally searching for just Steve Carell. But there are, what, like 20 or so shows that he's been in. All right, well, here's where things would get tedious. What are those shows? Well, I could do select title from shows where the ID of the show equals, and here's, whenever you copy paste, you're probably doing something wrong. OK, he was in the Dana Carvey show. Familiar with that? Well, let's do another one. We'll copy paste this, where ID equals this. Over the top, another. And if we keep digging, we'll probably find The Office. But my God, like that's going to take forever to do 20 queries manually. It's not very dynamic. But what if we just nest these queries a little more dynamically? So let me start from the beginning again. What if we go ahead and select everything we know about people whose name equals Steve Carell. That gave us earlier this data. I don't need all of that data. I know his name. I don't care about his birth year. So let's change this to just be give me the ID of Steve Carell. And that gives me back now this smaller temporary data set. All right, can I now use this inside of another query? Well, let me wrap the whole thing with parentheses. And now let me say select star from the stars table where the person ID equals this. So I'm deliberately not using in because I'm assuming there's indeed only one Steve Carell in the world. So I'm not getting back a list of Steve Carells. I'm getting back the one and only in this case. So equal is fine. In is when you have multiple. Equal is when you have one. Let me go ahead and hit enter now. OK, that's more data than I need. I don't need like 20 copies of Steve Carell's person ID. So let me hit up. Let me go back and let me just get show ID from Steve Carell. And now I have a list of just the 20 or so show IDs that he has been in. All right, how can I now use this? Well, let me hit up. Let me put the whole thing in parentheses. And now let me select what I really want. Select title from shows where, and here's the final flourish, the shows table has an ID, has a title, has a year, and has an episode. And what I really want, though, is to check which shows have ID that is what? Anyone want to finish the thought? I just want to, yeah. Exactly, ID in this. And this is getting ugly. And when you actually write your queries in like a text file, you can format them nicely and indent them. My font is just getting, I don't want to make it too small to fit everything. But now we have 3 queries. One is in doubly nested parentheses. Then there's the middle one. Then there's the outer one. So this last query is going to get me the title from shows where the ID of the show is in this big list of 20 or so show IDs that Steve Carell is in. And I knew that because I looked up his name here. And notice what I did not do this time is I didn't manually hard code his ID number. There's no need. That would be kind of a bad way to implement a website if you're using a database underneath the hood. You want the IMDb for real to search for whatever the human typed in, and no one's going to know Steve Carell's person ID or anything else. So here, we've done this all dynamically. And now, if I hit enter, I think I get all of his shows. Let's go ahead and order this by title just to make it tidy. And you probably will see at least one or more shows that you know. And probably the most popular is ... The Office. So this is literally the kind of query that's being executed underneath the hood when you go to websites or apps like IMDb. Your textual query is probably being plugged into a longer SQL query like this, where some programmer at IMDb probably wrote this whole query in advance, weeks, months, years ago, and they're just somehow plugging in the value that you, the human, typed into the search box or the like. Questions now on finding this data or any other? No? OK, so where else could we go with this? Well, let's consider how else we might combine data. Suppose that the next question actually, perhaps appropriately, would be focusing in on not just like people and shows and these stars, but how do we kind of like gather more information about the shows themselves, like the genres, the ratings, or the like. So indeed, let's focus on just these two tables here. Recall that every show has an ID, a title, a year, and episodes. But it also might have one or more relationships with rows in this other table called genres. And this is so that a show can be a comedy, can be a drama, can be any number of other things, one row per. So you would see the same show ID again and again and again with a different genre written in English, like comedy, drama, or the like. Well, how do I kind of reconstitute that data? Well, it turns out there's a few different ways to do this. And let me propose that we introduce this keyword here, join. And this is really the most powerful of the keywords in SQL itself. It doesn't have to be used. We've seen with nested queries that you can still select data across multiple tables. But here is another way. So let me do this. Let me go back to my SQLite database. And let me select sort of in one breath exactly the data I want. Select star from shows. And let's just limit this initially to 10 to see what it looks like. All right, that's again the shows data. Select star from genres. Let's limit that to 10 too, just to wrap our minds around it. And now this is not that useful. However, the data in the leftmost column here is the primary key in the shows table. These are just unique IDs. The data here in the genres table, recall, show ID is the foreign key. So it's the same numbers, but just copied into another table so that we can have this relationship across them. How do I kind of line up these numbers with these numbers to get back like a wider table that has title and year and episodes and genre and heck, ratings and all of that too if we want? Well, you can join these tables by just telling the database what to join on what. So let me do this. Select star from shows. Join that table, though, on the genres table. Well, how do you want to join those two tables? And again, the two tables from the picture looked like this. How do you tell SQL programmatically to sort of, put one of them right next to the other, line up all of the IDs so that you just get one larger data set? Well, we can use indeed this syntax called join. So back to VS Code here. And let me join these two tables. Sorry, typo here. Join genres on the shows tables ID column, aka its primary key, equaling the genres tables show ID column, aka the foreign key. So in other words, it looks a little cryptic, but I'm just telling SQL how to line up these two tables and what column to match with the other so that the numbers line up and I get essentially a wider table. Let me go ahead and hit semicolon and enter. And this is now going to give me a lot of data. We might have to interrupt it. But notice, even at a glance, we're getting the ID, the title, the year, the number of episodes, the ID again, redundantly, but that's to be expected if I'm joining them, and the genre all the way on the right. Let me hit Control-C to interrupt. Let me just limit this to The Office. So where title equals, quote unquote, The Office. So we can focus on just one sample datum. And here, fun fact, there's been more than one Office. The one that you all probably like is this one that started in 2005 with 188 episodes. Its ID in the shows table is 386676. That's confirmed over here too. So again, we've just joined the two tables. How? By lining up those fields. But now that we can see that almost all of the Offices produced over the decades are comedies, except for this one. There was a version of The Office produced in 2001 that was considered more of a drama. No, unsure if it's related to the other. How can we link in other data? Well, let's go ahead and link in ratings too, or instead. So instead of joining this with genres, let me go ahead and rewind here and join shows on ratings on shows.id equals ratings.showid. And let's limit it to the Office 2 for discussion's sake, where title equals quote unquote the Office, semicolon. And now you can see that among the various offices, it looks like the one that most of us probably know and love is the highest rated, also with a 9.0, with like 585,000 people having cast votes for it, whereas these other shows seem to have been less popular, and perhaps that's why, indeed, you see fewer episodes for them as well. So even though we've put the data in multiple places, you can still kind of reconstitute it by lining things up in this way and rejoining the tables. Questions now on this? This is the heart of what SQL does and what relational databases do for you. Questions? All right, a few final features. Like, there's not all that much that, SQL takes practice like anything else. But in terms of syntax and capabilities, let's just introduce you to a couple of final features here and problems that arise and how we might solve them. Let's do this as well. So let me go back into VS Code here, and let's just find out Steve Carell's information again. Last time we did it with this nested query by getting his ID and then the show IDs and then the titles for those show IDs. With join, you can do it a little differently. And any of these ways are fine. One might become easier to you mentally than another. Let's go ahead and select the titles from what? Let's select the title from the people table. And I'm going to hit enter. And when you're using SQLite 3 interactively, if you ever find yourself with a prompt that says ... angle bracket, it means you're continuing your thought onto the next line. If you didn't intend that, you can sometimes hit semicolon to just end the thought and hit enter, and just even if it triggers an error. But this is one way of formatting my queries now a little more nicely. I'm just going to add some white space so that it's a little easier to read. What do I want to select? Well, I want to select the title of shows from the people table joined with the stars table on the people table's ID column, equaling the stars table's person ID column. So in other words, if you think back to what people are and what stars are, one has an ID, one has a person ID. I'm just now connecting those two tables. I'm joining those two. But I want to do this as well with another table. Let me additionally join in. So now I only have two hands, but now I'm putting a third table joined in together here. Join shows on stars.showid equals shows.id. So this is now linking three tables together. But I only care about this for one person, so where the name of the person equals quote unquote Steve Carell. So more cryptic to be sure, but what we're doing with this query is just taking all three tables that we care about, and we're joining them all together at once using this new join syntax, literally telling the database what columns to line up with what. And then we filter at the very end, just like before, to get back, if I hit enter, the answer we want, which in this case is a little slower at the moment, but that same list of 20 or so shows that he's been in. There's one other way to do this. And again, these are all in the slides online, so you can repeat them without having to jot down everything. And we'll put them in the notes too. But there's another way to do this. I could also use an implicit join. So that was an explicit join because I literally typed the word join multiple times at that. But let me go ahead and select the title from these three tables: people, stars, and shows. And this might just be nicer because if you know what tables you want to select data from, just enumerate them, separated by commas, which you might prefer in your mind, where the people ID equals the stars person ID, and the stars show ID equals the shows ID, and the name of the person equals Steve Carell. So this is an implicit join. And honestly, I constantly reference my notes for some of this stuff too. It's not the kind of thing that's going to come like this to you after just one day. But it's just a different way of expressing the same thing. I want to select data from three different tables. And hey, SQL, here is how I want you to line those tables up so that I can get like-related data for Steve Carell. And this now will achieve the same results ultimately. Let me hit enter. And there we go. So a little slower, and the performance might vary based on computer, based on implementation of SQL, but I think I still have the same answers. Now suppose, as I'm often do, and I had to look it up again last time, suppose you forget how to spell Steve Carell's name. Is it two R's, two L's, or the like? Well, I could also do something like this. Select Well, let's just keep this simple. Select star from people where name equals. I've been deliberately getting it right so as to not embarrass myself. That's the Steve Carell I keep querying. If you forget, well, you could try searching for just Steves. But interestingly, there's a bunch of Steves. We don't know when they were born. But that's probably not the Steve Carell we want if we don't have his last name. So I could alternatively do, well, it's Steve, and then it starts with a C, I think. Well, it turns out there's another wildcard you can use in SQL. We used the asterisk to select all of the columns. You can, in quotes, use a % sign to say C something. So there's 0 or more characters after the letter C. And now this doesn't work, because now I would be literally looking for Steve space C something. But recall earlier I mentioned that one other keyword, which is for fuzzier matching, so to speak, where it's like not exactly what you're looking for, but it's like what you're looking for. If you instead say where his name is like Steve space C something, now we'll get back a whole bunch of Steves, but I think now I could probably find the one I'm actually looking for if I don't remember his name. You can use multiple % signs. If you forget what his first name is, you could reverse the order. But that, too, is a very powerful SQL feature at that. Questions on these queries here? Yeah? Sorry? What about it? Oh, yeah, sure. So the query I used here, there's a lot of Steves whose last name starts with C. Oops, too far. The last query I executed was this one here. So where the name is like, quote unquote, Steve C % sign. So that's just another tool for your toolkit here. But you'll perhaps have noticed that those two, prior to that query, the joins I did were sort of slow. And honestly, this database isn't even that big. Like, yes, it has tens of thousands of rows in it. But like in the real world, and most of the apps you and I use a lot every day, or websites, like there's millions, even billions of rows of data. And like if I had to wait on like my computer here or my code space like a second or two to get the data, like that's not going to work for millions of users or customers, certainly. So how can we actually improve things? Well, it turns out another upside of a proper relational database is that it's not just a spreadsheet where the onus is on like you to like find the data you're looking for. You can also tell the database to index the data for you. An index is an efficient cheat sheet for finding data fast. Like books in the real world often have indices at the end of the book where you can look things up alphabetically, and then you can cross-reference it for the pages that that topic appears on. Same idea in a database. If you tell the database in advance that you want to search on a certain column frequently, you can tell it to build a fancy index that will just allow you to search that column faster. By default, these columns are going to be searched most likely by a linear search, like not even binary search, because the data might not be sorted because it came in any order. But if you create an index, you're probably going to get something closer to logarithmic than linear, and that's going to be a big plus overall. So let me do something simple here. First, let me turn on a SQLite specific feature that just is going to time all of my queries by writing .timer on. I just want to keep track of how long each of these commands takes. This one is not a slow command, so this is just going to be relative. But let's just select everything from the shows table where the title thereof is The Office. Let's see how long this relatively simple query takes. All right, not very long at all. In real terms, like less than a second, 0.035 seconds. So not slow by any means. But if you've got hundreds, thousands, millions of users, like every one of those milliseconds could very well add up. So can we do better? Well, we can if I do this. If I use syntax like this once in the beginning of the design of my database, I create not a table, but an index with some name on a specific table on one or more columns. I can give a clue, a hint to the database in advance saying, please optimize with some secret sauce searching or selecting on this column in this table so that my searches are faster. So let me do this. Let me go back to VS Code here. Let me create an index called, how about title index? I could call it anything I want, but I want to search faster on titles. So I'm going to call this a title index where, title index on the table called shows. And then in parentheses is the syntax, the column called title. So again, I've just borrowed this canonical syntax, and I've just translated it into something that's TV show specific. All right, what is this going to do for me? Once I hit enter, this is going to create in the computer's memory, the database's memory, something called a B tree. It's not a binary tree. A B tree is actually a potentially more efficient data structure that we didn't talk about a few weeks back in week 5, but it looks a little something like this, which looks similar to a binary tree. But does anyone notice what makes this not a binary tree? Exactly. Binary tree, by implying 2, has no more than 2 children per node. But here's a perfect example, 1, 2, 3. And there could be 4 children, 5 children, or more. But the effect of that, if you have a very wide tree, the upside is that it's like very short. Like it pulls the data higher up, closer to the node, to the root node. And recall that the root node is where we began our searches in the past, whether it was a BST, a binary search tree, even a trie, or other data structures. We always began at the top. So the higher up you can pull the data, even if it makes the data structure very wide, you're going to be able to do boom, 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 look up queries, look up data probably much faster, certainly than if it's just a very long list, like a column by default. So with that said, let me go back to VS Code. I didn't create the index yet. Let me go ahead and hit enter and create it. All right, it took a moment. It took like half a second, which obviously is not that slow. But with more data, that could have been even slower. But it's a one-time operation as of now. And now, let me hit up. And let me select the same data from shows where title equals the office. Last time, just a moment ago, it took 0.035 seconds. No, not slow, but also that's going to add up if I have lots of users of IMDb. Let's go ahead now and execute the same query again. How long did that take? 0.001 seconds now. I mean, practically nothing. And so that's the sort of opportunity now. When you've got lots of data and you want to really speed up these searches, these indexes, these indices that just create for you these magical data structures in the database's memory, it allows you to search on columns that you are pretty sure you want to search on more effectively. Now, by contrast, if you've ever used like Google or Bing or some search engine that has advanced search, some of those text boxes that you can search more precisely in might very well be slower. Why? Well, probably you don't want to go crazy and just index every column on every table. Why? What might be the intuition? Like if logically indexes speed things up, why not index everything? There's always going to be a trade-off here. What might that be? Yeah. Yeah, it's going to take a lot of storage, right? This is just a slide on the screen, but like this has to go somewhere. Like this needs space in the computer's memory or on the hard drive or the like, and that's fine if you have unlimited space, but odds are like you don't, and that's going to get expensive for different reasons. So maybe you only want to index certain columns and certain tables and not all of them, because you know what? Even if a user really wants to search, maybe via advanced search on some other column or table altogether, fine. If once in a while a query is slow, like we're probably getting the bigger bang for our buck by optimizing the common cases, the more popular queries that people actually care about too. All right, so let's come full circle and bring this now back to how we actually began, which was with some Python code. So it turns out these are not either or decisions. It turns out in the real world, developers are constantly using 1, 2, 3 languages at once. In fact, next week I rattled off HTML, CSS, and JavaScript, one of which is a proper programming language, but those languages are often used together. Totally normal and common to use Python and SQL, or Java in SQL, or Swift in SQL, or any number of different combinations with a database language. You might use your preferred programming language, Java, Python, C++, to create the user interface and the logic that builds that implements the program itself. But for your data, like SQL is a really good candidate. And indeed, we've seen already that SQL can just speed up certain operations. You can collapse 15 lines of code into just one, and you can use these things together. So let me come back to, I'm going to quit out of SQLite. I'm going to minimize my terminal window. And here's where we left off before with favorites.py. With favorites.py, everything was being stored in favorites.csv. And recall that we eventually imported that CSV file into favorites.db automatically with .import, just so we can start playing around with SQL. But we can now tie these two together, and a way to do that is as follows. CS50 has a library for Python. You might recall having available getString, getInt, getFloat. You don't strictly need to use them in Python because it's much easier to just use the input function and then try, accept, and convert things to int or float or the like. But it's a lot more work to use SQL in Python without a third-party library. A lot of the commercial options or popular open source options are actually just complicated to use. So CS50 does have a very useful function inside of its library for Python that you should use and must use for the problem set that just makes it easy to execute execute SQL inside of your Python code. But it's built on top of a very popular open source alternative. So you can use that too in the real world. So the documentation for that's at this URL here, but I'll show you what we need to know here by focusing back on favorites.py. So what I'm going to do here as follows is this. Let me delete everything from favorites.py except for, let's say, this. From CS50, import SQL in all caps. So that's importing a SQL feature from CS50's library that's going to allow me to open a DB file in code. How do I do that? Well, let me create a variable called DB for database, though I could call it anything I want. Let me call this SQL function and pass in, using special syntax that's not CS50 specific, it's an industry thing, SQLite : ///. Unlike every other URL you type, this one literally has 3 in this context here. And then the name of the database, which in this case is favorites.db. So this is just a way of telling this SQL library that we wrote, but that works exactly like third-party alternatives, open favorites.db using the SQLite technology, if you will. All right, let's just ask the user a question. Give me your favorite problem. So we're going to use input instead of getString, but we could use getString, but they're pretty much the same for our purposes. Let's ask the user for their favorite. And now, in Python code, let us select from favorites.db all of the rows where students specified that problem as their favorite. So in SQL alone, it would be this. Select star from favorites where problem equals, and I'll do, well, whatever my favorite's going to be, like problem equals Mario, for instance. So if I were just using SQL, I would literally write something like that. But I'm in a .py file now. Like I have to use Python syntax. But Python supports strings. SQL is just text. It's just a string. So I could certainly just put my SQL code in a string, perhaps, and then pass it to a Python function. And here's the bridge between the two. If you just treat SQL as any old text, we can put it in a string and execute it. So let me actually do this. Let me go ahead and create a variable called rows, which is eventually going to contain all the rows from the database. Let me go ahead and select db.execute. This is the one function you need to know about inside of CS50's library, and it literally executes a SQL statement. And then in quotes, you pass it literally what you want to execute. And let me go ahead and close the parenthesis at the end there. And now let me just try this. So for row in rows, let's iterate over all of the rows. Let me go ahead and print out, how about row, quote unquote. And what do I want here? Let's print out the timestamp of that person for kicks. All right, let me open my terminal window. Python of favorites.py, crossing my fingers here for sure. Enter. There we go, favorite. So I'll type in Mario. OK, so I got back, it's not very interesting, but I got back all of the timestamps of students who typed in Mario that we imported into this database. Well, what I really care about is how popular Mario is. So let me change this a little bit. Let me change this to count the number of rows. And let me keep it simple. Let me give an alias like I proposed earlier, like as n, where n is a number, so that now down here, I can actually just do this, print out the value of n. All right, let me go back to my terminal window, run Python of favorites.py. Let me type in Mario, enter. OK, 39. Now, technically, I'm cheating. Like, honestly, if I'm executing select count, we've seen before, it only ever returns one row, not multiple. So there's really nothing to iterate over. But it's working fine. It's just iterating once, but I'm getting lucky. So technically, what I should probably just do is this. I should probably give myself like a variable called row, set it equal to the very first row and only row that came back, and now print out that row's n column. Let me rerun the program. I'll type in Mario again, enter, and I still see 39. So this, of course, I don't strictly need to do this. I don't really need a variable. I can do rows bracket 0 instead. But let me focus on what this library is now doing. So per the documentation, what the CS50 execute function always does for you is it returns a list of dictionaries. So if your query returns nothing, like no matches, you get back an empty list, like open bracket, close bracket, nothing in it. Any loop is not going to execute anything useful because there's nothing in it. If, though, you get back one row, you're going to get back a list of size 1, inside of which is a single dictionary. That dictionary is going to have keys that correspond to whatever you selected, be it the columns or the count. So when I selected star before, I would have gotten all of the columns. That's how I was able to access timestamp. Here, I'm just selecting count, and I don't want to have to type this down here. That would just look kind of atrocious. It would work, but it would look weird to just keep retyping count, paren, star, close paren. So I just created an alias called n, just to make my life easier or cleaner down here. So to be clear, the CS50 execute function returns a list of dictionaries when you're using select, and that is how I can now get back the first and only row and then print out that row's n value. It is identical to, let me do this. Let me highlight this whole line of text. Let me, in my terminal window, run SQLite 3 of favorites.db like we did before break. Let me just copy paste this query, enter. That's the table I got back earlier when we played with SQL manually. And so when I get back this table, here's the key, here's the value. And I only have one row, which is why I'm just blindly indexing into rows bracket 0, because I know there's always going to be an answer there. It's going to be 0 or 1 or more. But I know now it's going to be called n because of this here. So what have I just done? Well, this is SQL down here. And this is just me being like a data scientist asking questions about my data, just using like black and white SQL queries. This is me now being a Python programmer who wants to talk to a SQL database using Python. And the bridge we're using happens to be this CS50 library. But again, there's third-party free libraries you can also use as well. Ours is just very simple. And indeed, the documentation will explain how execute behaves a little differently for inserts, updates, and deletes. You don't get back a list because you're not selecting anything, but you do get back some return values. Questions on this? That's the last of our Python code that ties everything together in spirit. Yeah? What this one here? Yes, so db.execute, by definition, returns a list of rows. And each of those rows happens to be a dictionary because it's convenient, key-value pairs. If I'm selecting the count of rows, I just know from having learned SQL an hour ago that this is always going to give me a single row whose column in this case is called n. So if I know it's a single row, I can just blindly, just like in C, go into that list, or an array in C, and go to the first location, and then treat that as the single row. What you don't want to do is this. Even if you, the human, know the query returns one row, you can't just magically change the variable name to be singular and expect to have only one value. You will always have a list. So even if there is only one value in it, it's up to you to do something like this to get at it. Or if you prefer more succinctness, you can do rows bracket I bracket n. That'll achieve the same thing without a variable. Yeah? Good. So I have been misleading this whole time and cheating because this is only ever going to return Mario. I'm ignoring the favorite that the human typed in here on line 5. So let me fix that. And that's going to lead us to some of the problems that arise ultimately with SQL. The right way to solve that problem, let me get rid of my terminal window here. The right way to solve this problem is not to use an F string like we did in Python generally, because SQL queries, as we'll see in a moment, can be dangerous. When you want to plug in users' data into a query that you've written most of in advance, you should, you must, you had better use a placeholder, namely a question mark in this case. This is somewhat specific to CS50's library, but we just borrowed the convention that like every other library uses too. In the world of SQL, single question marks are used as placeholders. And the way you do this is as follows. If you want to plug in a value for that question mark, just like in printf in C, you specify as a second or a third or a fourth argument all of the values you want plugged into this. So in C, weeks ago, we were using %s. Same exact idea. In SQL, it's a question mark that you use instead. This now, if I open back my terminal window and I run python of favorites.py, type in Mario, I should still get 39, but now it can also type in Scratch perhaps and get 44 for that very first piece at 0. And that one is even more popular here. So this now is correct. It would work to use an F string here and then plug in a value like favorite here, but you'll see in just a moment, don't do that. You will expose yourself to potential hack or attacks by trusting the user's input. And so in fact, let's transition from that to exactly some of these kinds of challenges, namely 2, before we wrap up. So in the world of SQL, especially when it's used at scale, at the Twitters and the Googles of the world, like lots of data is probably coming into the database all at once because multiple people are opening their phones at the same time around the world. They're clicking on the same links roughly at the same time around the world. When you have thousands of people all using your site at once, like order of operations is going to be important. But unfortunately, in SQL and in other contexts of computing, there's this risk of what's known as a race condition. So for instance, has anyone ever seen or liked this? This is like, guess the world record egg. All right, it's like this thing that was very popular a while back. It's still kind of going strong. But if you go to the Instagram profile for world record egg, the goal was to make the most liked Instagram post ever. And they did pretty well. It's just this. It's just a picture of an egg. Now, at the height of the popularity, like there might have been hundreds, thousands, tens of thousands of people clicking pretty much at the same time on this egg. So it actually creates a potential problem with the integrity of Instagram's data. Why? Well, if you have all these requests coming in at once, how do you possibly keep track of all of them and update your counter in a way that can keep up with all of that traffic? Why? Well, let's just hypothesize what Meta, formerly Facebook, was doing underneath the hood with Instagram if this were their code. So suppose, for the sake of discussion, that Instagram servers are using a mix of Python and SQL. Probably not using the CS50 library, but they could absolutely be using those 2 languages or 2 others together. Suppose they do this in order to update the number of likes for that post. They first execute a SQL query like select the current number of likes from a table called posts, where the ID of the post equals whatever the unique identifier is for that specific egg in the table. And then they store the result in this rows variable, just like I did. And then they do this. They create a variable called likes. They set it equal to rows bracket 0, so the very first row in the result set. And they get the likes key. So this is literally what I just did with the count. Let me hypothesize that Instagram does something similar with the total number of likes. Why are they doing this? Because they then want to execute a third line of code that executes update the posts table, set the new number of likes equal to something where the ID of the post equals this other thing. Now notice, just like in printf, there's the comma-separated list of values. They want to update the current number of likes from the current value to the current value plus 1. So it's likes plus 1. And then we plug in the ID for this. So suppose this is what Instagram's doing. Unfortunately, whenever you execute multiple lines of code independently, and you're so popular like Instagram that you have thousands, hundreds of thousands of servers potentially, it is quite possible that if you and I and everyone else in the room clicks that egg at the same time, it's not going to be the case statistically that like 3 lines of code are executed for me, and then 3 lines for you, and then 3 lines for you. They're probably going to get interspersed. Like this gets executed for me, and then this gets executed for you, and then they get back to doing work for me, and so forth, just to kind of multitask, just like a human might, but at a super speed here. The problem, though, is if these lines of code get interrupted, what could go wrong? Well, suppose that Carter and I both click the egg at the same time, and suppose the current number of likes back in the day is 100. That stores in this variable the value 100. But if we click so close in time, we might get back the same answer to this select query. As of that moment in time when David and Carter clicked, it had 100 likes. But then this last line of code is executed for me and then maybe Carter. Because that answer, the state of the database, was stored in this variable, then both Carter and I will result in this line of code being executed with the same value. Update the posts table, setting the likes equal to 101 for that post's ID. Why? Because again, if each of these lines of code running on different servers are checking the value of the current number of likes, but then getting interrupted because Carter clicked the darn thing too, and then resuming their work on my behalf, we might have a race condition where the code is sort of racing to finish, but getting interrupted by other users' clicks. And the problem with that is that if you are inspecting the value of some variable, or in this case, a database cell, and making a decision based on it, like how to update it, you might now lose data. And Instagram, probably not good for advertising if they're losing likes. And so that's probably a problem, not to retain the value 102 and instead insert the number 101 twice. It's actually similar in spirit to a story that was told in a databases course I took myself years ago, whereby it's somewhat analogous to kind of a contrived scenario involving like a refrigerator. And this is the closest thing to a refrigerator we could get on stage. But imagine you've got like one of these little dorm fridges in your dorm too, and your roommate. And maybe both of you, as the story was told to me, really like milk. And one of you's at class, but the other of you comes home and you open your dorm fridge and you're like, oh, darn it, we're out of milk. And so you close the fridge, you walk across the street to CVS or some other store, and you get in line to buy some milk. Meanwhile, your roommate gets out of class, they come back to your dorm room, they're really thirsty for some milk, they open up the fridge, they say, oh, we're out of milk, and then they take a different route perhaps to CVS or some other store nearby, get in line to buy some milk. Fast forward some amount of time in this very contrived story, and what happens, oh, damn it, we now ended up with like 2 gallons of milk, and there's no way we can fit gallons of milk in there, let alone 2 of them, so that's a problem. But what's the relationship to this here? Well, both of us, yeah, did what? Exactly. Exactly. So to summarize, both of us had a very similar thought process, made a similar decision based on the same information, not realizing that the information, the fridge, was in the process of being updated. And it, of course, in the Instagram world happens like this. In the fridge world, it might take a few minutes, but the problem is ultimately the result of our having made a decision about the state of the world, and the state of the world was in the middle of being updated. The queries got commingled with others, or in this case, someone was already on their way to the store. So what's the solution in the real world? Well, you could, very simply like take a Post-it note and put like gone for milk so as to communicate to your roommate that they should not inspect the value of that variable and make a decision on it. Why? Because it's not yet consistent with the outcome that's about to happen. You could be more dramatic and you could actually lock the fridge somehow, put a padlock around it or the like, so they can't even get in there, and that would achieve the result, the same effect too. And that is actually pretty much the solution to this problem in code too. It's not safe, it's not sufficient to only execute 3 lines of code like this. Rather, what you probably want to do is use additional SQL keywords that we won't spend much time on in the class itself, but these. There are solutions to this problem. You can begin what's called a transaction, and you can more explicitly commit to making a decision, like updating the database to 101 or 102. Or if you realize, wait a minute, Carter's query is interrupting mine, let me roll back to the previous state and just rewind. Let me undo, Control Z, if you will. There's also another keyword that's not so much used anymore in SQL, which is locking. You could literally, back in the day, lock the entire database table, preventing anyone from updating it or making changes or even reading it while someone else was accessing it. That was a very heavy-handed solution because it slowed everything down. But in short, transactions are now a feature of SQL that you won't necessarily need to use yourselves that do solve this problem by doing the equivalent of saying, while David's like counter is in the process of being updated, keep Carter at bay, ideally briefly, and then let his data go through too. It's equivalent to putting a note or a lock on the fridge. And indeed, I mean lock literally. They were once upon a time called, and still are in some texts, called locks on databases too. And the last and the code for which you might do this is almost the same. You simply wrap the 3 queries with a transaction statement and a commit. And the term of art here is that this makes your statements atomic. So atomic means they're either all executed or not at all. That is, they're all very tightly coupled together without interruption. Transactions solves that problem and avoid having 2 gallons of milk. And the last problem that arises that is tragically so darn common in the real world today is what's called a SQL injection attack. And it's what I alluded to earlier with the question marks. So suppose you're in the habit of logging in to Yale websites with your NetID or password, or at Harvard, your Harvard key and password as well. Suppose for the sake of discussion that the people that implemented like Harvard key login allow you to type in your email address, of course, and your password. But suppose that they are using SQL underneath the hood to check your username and password to make sure that you are David Malin or Carter Zinke or whoever you claim to be. I haven't shown you the syntax yet, but it turns out that in SQL, dash dash is a special way of indicating a comment. It means ignore everything to the right. So it's just like slash slash in C or the hash symbol in Python. Dash dash just means ignore everything to the right. And we've, of course, seen single quotes. So one way to wage a SQL injection attack is to try to inject malicious SQL code into someone else's database without them realizing it. How do you do this? Well, suppose I log in as malin@harvard.edu, single quote, dash dash. I'm not double quoting anything clearly, and there's nothing to the right of the dash dash anyway. But this imbalance is going to be useful. Why? Because if I'm a hacker and I'm presuming, someone at Harvard probably is using single quotes to wrap the user's email address and wrap the user's password, what if I try to complete their thought for them and close one of those quotes for them? What might happen? Well, we could do this. Here, for instance, let me hypothesize is the code that Harvard wrote, hopefully not, underneath the hood. So they're using CS50's library in Python, and they're using SQL inside. Suppose that they have a query like this. Select star from users where username equals question mark and password equals question mark. And then suppose they just plug in whatever username and password was typed in. And then if they get back some number of rows, dot, 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 they assume I am David. They assume Carter is Carter if both the username and password are in the database. Just end of story there. This is good. This has the question mark placeholders we discussed earlier. But what if you don't quite remember that? You don't quite take that to heart, and you use your more familiar last week f strings, whereby we use these curly braces to plug in values. What if you do this instead? So it's almost the same idea. It's still db execute, but now it's select star from users where username equals. And now notice I'm doing the single quotes, which is required by SQL, but I'm using f strings with the curly braces. And the password equals single quote, password, and then close single quote. The problem is if you're just blindly pasting effectively the user's input into that web form into the username field and the password field, there's nothing stopping a malicious user, student, faculty, staff from including a single quote in their name. Or maybe even, benevolently, if their name happens to have a single quote, as some last names in particular do. So this is very fragile. Why? Well, suppose that if we plug in my malicious value, malin@harvard.edu, single quote, dash, dash, notice what happens to username here. The username variable inside of the curly quotes will get replaced with this. And notice, single quote, which the Harvard programmer wrote, MALAN@harvard.edu, single quote, which I wrote, dash dash, which I wrote, single quote, which Harvard wrote, and whatever else they want after that. What's the implication, though, of the dash dash? Everything to the right is going to be ignored. So the password is never even checked in this scenario. I'm tricking the server into ignoring everything after the dash dash. But I have constructed very cleverly, very maliciously, a syntactically valid query. Why? Because I provided the single quote that's going to finish the thought of that first single quote. And now, I would only know how to do this if I saw the code or if I just randomly try putting apostrophes into web forms and see if things break. That's often how adversaries attack systems. They type in potentially dangerous characters, hit enter. If something breaks, they're not necessarily into the system, but they know that there might be a vulnerability. And then they start trying more methodically things like this. So this then is going to be bad because it effectively grays out the rest of the query. And this query is surely going to return some rows without even knowing my password. And so this logic here, dot, 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 means, well, if data came back from this query, Harvard is presumably going to assume that Malin logged in, show him his account, or whatever is being protected here. So in short, using f strings, bad. Using any equivalent like %s in C, bad when it comes to SQL. Using question marks or whatever a third-party library like CS50's prescribes is the way to solve this. Why? Because libraries like ours are designed to at least be smart and be paranoid. And what we will do is this. When you use the question marks and the values are plugged in, we will escape any potentially dangerous characters inside of those placeholders. And so effectively, the single quote will no longer be considered a grammatical single quote. It will just be literally a character in the username or password. So the library takes care of this for you because you're plugging in the username and password as separate arguments. And then we, or the third party you're using, actually sanitize, that is, clean up the data and prevent those bad characters. Now, this is kind of an internet meme that went around for a while. If you've ever driven a car, been in a car where there's like the automatic readers for tolls, this person thought it might be funny to try doing something like this. What are they presumably doing? The presumption here is, whether or not it worked is unclear, is that here's like the end of an actual license plate number, but here's an interesting single quote and a semicolon. That's especially bad because it means you can maybe execute a second query on the database. This is someone having fun trying to drop the entire database table for whatever municipality is scanning through cameras their license plate code. And I would be remiss if we didn't end on this note. At least in computer science circles, there is someone named, no relation to the TF name we put in the database earlier, Little Bobby Tables, which ends with this XKCD comic. And if you chuckle, if you laugh, you're now legit SQL programmers. Nice. Nice. Like every CS student out there knows about Little Bobby Tables. So if you name drop Little Bobby Tables now, like you're in. All right, that's it though for today. We will see you next time.